program do come on annual basis, and the Compodet is Committee of Deans of Polytechnic and Colleges of Technology. This very particular group is set up to oversee the administration and the technical know-how of the Polytechnic by the CORE, and is under Council of Regulation of Engineering in Nigeria. This 5th edition is the 5th for the student and ND, HND project program, while this is the 2nd edition for the staff innovation competition. We are here, we have our assessors here, so they have been here since around 9 o'clock as planned. By God's grace, we are commencing now, and I want us to be fully attentive. Among our assessors, Engineer Isaac Agbonika from Area Council.
Area Council is condition, sir.
So he's the Deputy Director, Engineering Maintenance. We have Engineer Aliu Basir from Federal Ministry of Works. So he's the principal engineer. Is here as one of our assessors as well. So I want us to recognize him. We have Engineer Kasim Marwan. So he's also in the other side for the other session. We are waiting for other 2 assessors. They are on their way. I want us to be attentive and listen to National Coordinator, who will give us the background of the time you need to spend in your presentation. We want you to be precise and go straight. Then he will give you the time and the time for question and answer. So the essence of this is to showcase what each zones have actually done in their zones, because we have had zonal competition initially: Southwest zone, Southeast zone, South-South zone, North Central, Northwest, and Northeast. So the winner of each zone now come here to assemble for the final. So the winner in terms of 1st, 2nd, 3rd on the National Diploma category and higher National Diploma category, and 1st, 2nd, 3rd from, it can be individual projects or group projects. As well, for the staff innovation, we don't accept group projects. It's only individual. So those are those people that will come to compete, and the best thing we match among them, so which we show up tomorrow at 34th current assembly to receive their award. So I wish you the best, and I pray that God Almighty will spare our life to witness more of this. Thank you for coming.
In our midst is trained specialized assessors. They are experts in various fields. As you are all aware, we have conducted the zonal competitions. Let me use this medium to congratulate you based on the submission by our zonal coordinators. The presentation is 10 minutes, and question and answers is 5 minutes. So without wasting much of time, let me hand it over you to the assessors. We are starting with this Bodorisho Matthew from Federal Polytechnic AD. Is he present? Grant here. Is this HND? No, this is ND. Is it ND? Yes. Okay, sorry. This is ND. Yes. For the HND.
Ajala, Ifeoluwa.
Yes, sir. The title of the project is what? What is that?
That's number 1.
Design and implementation of rechargeable included. Okay, to the time, let us start with the second person.
That is Edo,
Who is the deal?
Olumide.
Where is the deal? Hold on. Okay. Yes.
Slide, you let's slide it, let's slide it down. Resume. Point.
Okay. So you mean the relationship is this side?
Sorry, I'm blocking.
Okay, granules.
Good day, sir. My name is Idowolmide. I'm here with me for Adam. We are here to present the design and fabrication of granite sheller. So, to start with, granite remains one of the most widely cultivated cash crops across the sub-Saharan Africa, which consists of 47 countries in Africa. So it is significant to both food production and rural income. So I'll continue with this project seeks to solve the problem through the design and fabrication of mechanized groundnut sheller that is efficient, affordable, and easy to operate. So now, the aim and the objective for this project were to design and fabricate a low-cost, efficient groundnut sheller machine. Our objective to design a mechanized groundnut sheller, that is, we have to develop the electric motor and petrol engine, which means it's the engine power that powers the machine is detachable, and to minimize groundnut damage. We discovered that the rate at which the groundnut is being damaged through the manual using it's actually high. So the project solves to minimize the groundnut damage and to improve process speed and efficiency. Due to the high demand of groundnut in the food production industry, so there is need for the processing of the groundnut sheller and its efficiency. So we'll start with the problem statement. The high demand in food production, that's one of the reasons for this project. And the two, the labor intensive and time with the groundnut is being processed while after the harvest. And three, high groundnut damage. So the manual shelling frequency result in crack or broken groundnuts lead to quality loss even for the farmers. So the scope of this study, the design and fabrication focus on a small scale in which it consists of the motorized and the petrol engine groundnut shelling machine suitable for the rural and the semi-urban farmer. So the machine is intended to process the groundnut pond, ensuring the efficiency shelling and a low groundnut breakage. So this means that it can be operated both on the electric power and the petrol engine using a belt driving mechanism and designed to be portable. It is portable for the small scale farmer, user friendly and easy to maintain. So, in our research of the traditional shelling method, the shelling method starts with the hand crushing. So the point crush between the thumbs, we use the hand to crush, and the metal and piston. So groundnut shelling that started with hand crushing, metal piston, and manual shelling also. The manual shelling machine is hand operated device, which also causes fatigue while operating the manual device. So the limitation of the traditional approach. The limitations of the traditional approach to the groundnut shelling machine. 1. Load throughout and high labor. So the manual rate at which it is being processed is 1 to 2.5 kilograms per hour. But we cannot meet the high demand of the groundnut in the food production industry. 2. The high groundnut breakage, the rate at which the groundnut is being broken. So the uncontrollable force in manual method. So when the force used in the manual method, it actually causes the groundnut breakage. And 3, the ergonomic and health risk. So the repetitive motion of using the hand, it leads to fatigue and the lack of this causes fatigue and the long-term health issue. The components for the tools used in this design, the component on the left hand side and the tools on the right hand side. The upper frame, shell shaft, driven pulley, collector, flow bearing, belt, motor, blower, and driven pedal. So the tools we use, the angle ginger, welding machine, drilling machine, the measuring tape we use in fabricate the machine. So these are the components and the tools for the project. So the working principle of this project. So the groundnut sheller will be always operated based on a mechanized friction and the air separating and the air assisted separation. So the groundnut will be poured into the machine. When the groundnut is poured into the upper, so it directs it into the shell shaft. So it's connected to the electric motor or the petrol engine. So which rotates continuously, causing the bulbs to rub against the valves. So and against each other, which cause the bulbs to crack, and the shell process occurs. The mixture of the broken shell and the groundnut drops down into the collector. So to enhance the separation, the blower is attached the blower is integrated to blow the shell particles and the granite fall into the collector. That's the working principle. This is the project design. We have to do the design and ensure to be sure that this is actually going to work. So this is the project design for, before we carry out the fabrication. So the fabrication, this is the fabrication process. One, the material selection, so and the cutting, the mixed steel sheet and the square pipe. So these are the material. We get the material selection, the frame construction, the measuring, and the length for the project. So the three, the shelling chamber and the upper fabrication. So we go through the shelling chamber and the upper fabrication. The first step we have to take is the shaft and the pulley installation. So we have to install the shaft and the pulley installation. So and the fifth is the electric motor and driven assembly, which is also detachable, and we can also make use of the petrol, the engine. So in the blower integration, after we integrate the electric motors, so we have to integrate the blower, which is going to separate the granite from the shell. So and we finished, and we actually coat and clean and paint the fabrication, the project fabrication. So this is the result and the performance. The cost of the fabrication is 220,000 naira for the motor engine. Like I said, it is dual. It can use the motor engine and also the petrol engine, and the 340 for the dual petrol engine. So why using the two? So the shell efficiency is 85% for dry granite, ensuring effective separation from the shell. So it's capable of shelling 50 kg per hour, comparable to the manual, which is 1 to 2 kg per hour. So of granite, while maintaining efficiency. The system test was carried out with 500 electric motor using granite seed in various quantity. That means the smaller size, the bigger size. So this is the image showcase after the fabrication of the machine. So, and this is the AutoCAD, the design, the SolidWorks design of the machine. So, and this is the working principles. This is the working principle. This is the shaft. The shaft will rotate. When the granite is being poured into the upper, it comes down into the shaft. The shaft actually rotates, and the principle at which it works is by shelling the granite away. It crack the granite and it shell the granite from the shell from the granite, and it goes down into the collector. It goes down into the collector. The blower at the back actually blows the shell and ensure that the granite was being collected through the collector. Thank you very much, sir.
Okay.
Thank you for wonderful presentation. Any question? Any question? Okay.
First of all, I want to congratulate you for making a wonderful presentation on design. I just may want to make a suggestion for you. I think when you guys have done this very wonderful design and construction, your intention is to probably after you finish with the prototype and the manufacturing, I think you try to market your own. So the question here, have you carried out market survey? It is very important now. You can be able to fabricate this machine. If it's a single machine, such as the 220,000 naira. This is the dual 340,000 naira. The most important thing is now to go to the market and find out this similar type of machine, how much are they selling for? So that you can make comparison. Because me, if I go outside to buy this particular machine, I will go and make a survey. Because we have different companies, the market is very competitive, isn't it? So you better go and do comparison and find out whether your own product, is it the cost of your own product, is it higher than the cost of existing technology we have in the market? It is very, very important. Otherwise, you end up making the fabrication. After you put it in the market, nobody will sell it because of high price.
Thank you.
See,
Sorry.
it's like the first slide.
Okay.
The fourth slide.
Are you going to ask question?
Yes.
Okay, before
The fourth one. Go for it. Okay, fourth slide. So the next one, please. Next slide. The next one. So, next. It's all right. Did you carry out any research to get this breakage of 50%? How did you do it?
We visited
Louder, please, louder.
we visited rural and local areas. All those women are selling like on like for daily basis. So we noticed that they are using hand to break it. So it forces breakage. We like when we estimated everything, it was about specified percentage.
One place or how many?
Like several places around the environment.
And again, in case of any stone, how did the stone? How did you remove the stone from the bracket?
In case of any stone, it's actually a risk. That's why we recommend to actually sheave the granite and dry for the shelling of it.
Okay, Mr. President, while my senior colleagues talk about the cost effectiveness of the project, my question is that have you taken into account the local content of your project? Local content.
This is about 90%.
90%. What's the cost of that electric motor?
70,000.
Electric motor alone taken about 40% of the cost of the project. You are saying it's up to 90%. Okay, so there is certain criteria you need to adopt in using your blower to separate the shells with the main granite. What criteria have you adopted to blow the shells at the same time leave the seeds?
We noticed that the shell has lighter weight.
Just say gravity. It's okay. Then you said DC blower. What do you mean with that DC?
It's connected to the electric.
But the power is driven by the shaft and the pulley. Why do you use this? Yes, I know there is DC fans or blowers, but yours is being driven using what? Belts and pulley. Isn't it? Okay, that is my question.
So the last, bring back to the last, next slide, please. Before this one. Or go back, please. It's all right.
Is it after frying that she can bring the granite to this station?
Yes.
You fry manually. You fry the granite.
Dry it.
You don't have to dry it.
Okay, you don't dry it.
Yes.
You sun dry it
Yes. To ensure the shell is dry.
before you fry.
No, we're not frying.
Okay, you don't fry.
Yes.
They are not removing the inner shell, it's the outer shell.
Okay, you sun dry it
Yes.
before bringing it to the machine.
Yes.
Okay, I think this is an interesting topic. It's okay, thank you.
Listen, if you have to use petrol to run the machine, what the costs?
that's why we made it to work. So that for areas that like source of petrol engine, like the petrol is scarce, so they can use electric motor to power the machine. But for rural areas, like that there is no electricity, so they can afford the petrol engine to power the machine.
Speak out. The goal, right? What is the limitation of this project?
We notice that, like, for further improvements, we can change the electric motor or petrol engine to solar powered machine.
Good.
For better efficiency.
That's what I want to hear. Thank you very much. Yes. Yes. Yes.
It's all right.
Thank you, sir.
The next person, are you set? Time. Okay, let us call the next person if yours is not ready. Why is Abiodun?
Who is the next person?
Abiodun.
Abiodun Monday.
So,
Let me see your hand, please.
Good morning, sir. My name is Abiodun Federal Polytechnic Skill. Topic is development of eco-friendly glucose monitoring medical devices. As we all know, according to WHO, we have 830 million dealing with diabetes due to what? Our glucose level in our body. Because glucose, it helps and fuel the cells in our body to do what? To energize us to think, then walk and blink. The way we blink is the help of glucose in our body, and it uses what? It uses insulin. So insulin is hormone in our body that causes those cells in our body to do what to do. There are high glucose in the body, which is blood sugar in the body. Please help us to take this so to reduce the glucose in your body. So that's when you now go to the insulin will take the glucose in the body from the blood to what? To the cells. So it will absorb it, so it will not reduce it. So to avoid the heart attack or high vision or maybe stroke. Then diabetes. Diabetes is a chronic disease that occurs either when the pancreas does not produce enough insulin. Those insulin that carries those glucose to the cells is produced by the pancreas. So it can, body cannot effectively use the insulin it produces. Insulin is a hormone that regulates the blood glucose. As I said earlier, the insulin, it helps to carry those glucose in the body, to reduce it from your body, for you to be able to work, think, and blink, and do everything that you want to do on time. So it will help you to carry it to the cells. Those cells will absorb it. Then when we now have insulin resistance, that's when those cells say, no, we won't take this anymore. That's when those glucose will now fall back to our body. That's when we now have glucose strokes. You see, because a woman or all those our grandmas at home, they will just carry them up and down. That's the work of diabetes. Due to what? Those cells are not responsible, they are not working properly again. The second of the problem, due to the global rise in diabetes, present substantial challenges according to SDG, goal number 3, which says about good health and well-being. Because when you have good health, you're able to do what? Function and do whatever you want to do. So, and SDG is one of the SDG goals too, number 3. So, for healthcare systems and individual analysis, it always benefits us. So, we have come up with a device that we're able to test the glucose meter in our body. How is it? How is my glucose meter in my body? Is it something I can be able to prevent, or that will just leave it, shall we die? No, because everybody is scared to die. So, traditional glucose blood monitoring methods like fingertip test are invasive and inconvenient. Going to the hospital every time to check your glucose level is inconvenient. So it's a thing you can just have, sit down at home and test yourself. Okay, this thing is high. How will I prevent it? In the morning, maybe when you woke up, you take a water just to neutralize your body. For your body to what? To stay alive, to stay active, or you walk around the house. So just that's a little exercise you can just do in the morning. And there are some foods that causes those things. When we eat a lot of starchy food, those are the things that causes those diabetes, because they have a lot of sugar, and when they are not in our body, they will malfunction. Then leading to poor compliance among patients. Patients are complaining about diabetes. Millions of people have diabetes, but they don't know. But this way we're able to, okay, this diabetes is high. Okay, this my blood sugar is high. Okay, let me call my doctor. Let me do this. Let me do that. So these are the existing design that people are using. But for people to get this, it's kind of hard for them. Then it's more expensive. We only depend on importing them. What if we do this thing in our own local home and test it ourselves? So that's what we come up with this methodology. You have the sensors. The sensors that we use is BH67 left, 2472. That's the microcontroller dealing with this thing. So we deal with the SOD, the alarm system. The alarm system there is just to tell the person that is testing that this thing is higher, you have to do something immediately. In case people that have a side problem that cannot read the LCD on the meter, but when there is alarm, please come to check, this thing is making noise. Or is it that you call this or our parents or our children? Please, this thing is making noise. My blood glucose is like, what can I do to it? So the initialize, when you on it, it will initialize, then calibrate the tester strip. We have a test strips that we input to this device that are able to check just a drop of blood to test it. So the microsensor will sense, okay, this thing, okay, this is the result. And the glucose level ranges, or normal glucose level is 70% to 100. That's when you know, okay, this thing is normal, I can still do it, manage my life and stay active. Then alarm activation for abnormal glucose level, I said earlier, the alarm there will signal to you, boom, 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 this thing is abnormal. That's what you know that, okay, I need to check my glucose level. Then the efficient power is managed with power bank or battery. There is battery in it that power is, and which will last for 24 hours before you're able to charge it. For instance, when we went somewhere or you are not at home, you take that long. Then it will last for 24 hours for 2 days. Then if you have a power bank, you see Type-C, you can use it to charge it, power it again, and you are using it. This is the circuit diagram and the block diagram. As I said, this is the BH67F27, the microcontroller, as I said. Then the SOD, the buzzer alarm that will alert you, then the power system, then the glucose test meter. That's what you put on the device to test. Then this is the circuit diagram, how everything is connected. Those are the SOD, microcontroller, text, Then light emitting light, that's those red lights that will signal. There will be a light on it. Pum, 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 that will signal to it. Then these are the results. We've taken 12 people results. The first person we took ate, we asked him, he's a male, what did you eat last night? He said, banana and jam. Okay, nice. We test the diabetes test. It's no. Because what? The level is in 83. As I said earlier, 70 to 100. That's when you know, okay, this thing is normal. Let me judge. But when it's higher, that's when it's going to diabetes level. Then the second person, no. Then the fourth person, as we see, then Papa and Akara, is more than 200. It's 200. So this thing is higher. Sir, this thing, you have to go to the hospital. Or how are you eating? What are the food you are eating every day? So you have to reduce your starches food and try to hydrate yourself. Try to drink more water efficiently. Because water cures a lot of diabetes. It helps a lot when it comes to diabetes. Then we have some that don't have diabetes, a male that don't have diabetes. Then the last one again, ate an okra, have diabetes again. This is 135, is high again. So there's the chart we took. Then this from age 1 to 18, that is what test the glucose meter in the body. This is the range. The median range when the thing is low, maybe 70% milligram. Then when it's high, 82, you know this thing is happening. There is need to check.
You have 2 more minutes.
Yes. Thank you, sir.
You have 2 more minutes, Yolanda. Are you done now?
Yeah, that.
First of all, once again, I present a very nice project, HND level. But being we, your teachers at polytechnic level, the main thing is that we should guide you so that you can be competitive with the university graduates. I have gone through your project, but there are certain things which you need to do in order to improve the project. Throughout your own presentation, first of all, there is no citation. You have made very weighty statements, especially in the introduction, which you need to insert from where you obtain your state. It's very, very good. Because in our own, in the literacy world, we didn't work alone. We have a lot of projects going on. We have a lot of researches going on. And if you make a very weighty statement, if you don't want an academic to challenge you, you better put citation. It's very, very important. Secondly, I have seen some pictures of the existing method, isn't it? So you have to come out very clearly and state the limitations of this existing method. Because what we need to do is to improve. Technology is, every day we need to improve the present technology. So you must, first of all, you have to find out the limitation. Where is the pitch please of the existing method? I think some tree diagram, what is this one? This one, oh, there are different methods of carrying out the test, isn't it? Yes. You find out the limitation, what are the shortcomings of this method. And your own project, I'm just guiding you, and your own project is to overcome this limitation. You have to bring it out very clearly in your writing. After you have done that, I think you have made some measurement and you come out with a result, isn't it, from your own method? Yes. The most important thing is now to compare your own result with this existing. That's what we call benchmarking. It's very important because if you try to publish this result in a paper, they will not accept it because you have not done benchmarking and a reviewer of many journal articles, journal papers. So it's very, very important for you, after you have done your own measurement, you get your own result from your own method, you have to also carry out experiments of the existing methods and you compare to prove that your own is better than the existing one. This is what you need to do. Maybe probably you'll be going for masters, isn't it, after you finish your education. So mark you, this is very, very important. Thank you.
Thank you, sir. Thank you.
Appreciate it.
Hey,
Please, what's the cost of the project?
Because of the project.
Cost of the project is 45,000.
45,000 naira. How much can you get the same type of money?
If you want to get this type of the market now, if you want to order it, you have like $20 to $30 to import it to Nigeria.
Are you sure?
Yes, check and guess, please.
I think they want to use battery, right?
Yes, just in this battery.
What battery are you using?
Like a lithium battery.
Which one?
Lithium battery.
And how much that cost me to place in the market? How much?
That one is not some, maybe 1,000. When I get this one, it's 1, 2.
1, 2.
Yeah.
Okay, Mr. Abiodun, the daddy in our midst has given you a very good advice from his wealth of knowledge and experience. Backing on to that very, very well. And that is the area I wanted to take on from you. But there's a kind of trying to, so I will not go there too much. But I will want you to compare what makes this particular machine better than the one, the existing one in the market. Then, second question, this is I will call it glucometer, right? How does this device calculate the glucose level in human body?
First one, the differentiation between this one and this prototype. This is a prototype of what we are coming up with, and it already been done. This one, they have factory doing this. They have a lot of machine doing this. When they first start, it might not be smaller than this, but as time goes on, they are minimizing the size. Likewise, this one. This is what will come up with first time. So this is the prototype of what we are going to do. This one is different from the other one because why? Because this one, they have a specific and unique test strip you can use for it. You can't just buy this strip and use it for this one. It won't work. But this ours, you can go to a chemist or pharmacist. Please, I need a test strip for malaria. They will give it to you. You can just test it and use it on our own. That's one. Then the two, this one, you don't have to. This one does not give results. But at the recommendation of this one, we are working on our list to have a cloud and mobile app, in which when you tested yours and there is alarm, it's not that when you are blind you don't see, then there is nobody at home to talk. It will alert your doctor. Everybody has a family doctor at home that will consult. Instead of you going to the hospital, your doctor will be alert. This so patient is having this issue. Can you attend to it? Then you can just link maybe your firstborn or your children to it. So it will alert the doctor and your children that this thing is happening. Can you attend to it?
Thank you.
This is the limitation for the existing method.
Okay,
You are proposing something. This is why what I'm telling you that it's now you are bringing out the idea when you have explained. You have in your write-up, you have to, when you say, you can tell that the audience or the reader that in the existing method, so methods have been used, using so component, but the limitation is that it can't, it's not real, it is not real time, you can't get, it doesn't provide real time message of the result, isn't it? Yes. But your own is trying to address that limitation.
Basically, the microcontroller, which of the microcontroller?
EA67F2.
Then the program and
We use C program.
C program. Okay. On a lighter note, this is your matric number. It looks very interesting. 009. What does that signify?
That's my matric number in our school.
As the ninth.
Yes, number 9.
Number 9. In your school. It's a new school then. That's a new department.
Yes.
Okay. It's interesting.
Thank you, sir.
It's all right. Emmanuel, good job. We'll check. Manuel.
Yes, sir.
John.
Yes, sir.
What's your name, please?
Down, down.
ID card, please. Why? Let me know what is John. Let me know John here. No, I don't know.
Registration that shows your picture.
Where's John Bosco? Yes. Yes.
Morning, sir. My name is Manuel Udo Jones. I'm representing electrical and electronic department from New Technology Polytechnic Zaria. With me here is a project titled Design and Construction of Wireless Fuel Monitoring System in Police Station. So the increase need in efficient and real-time monitoring fuel gauge system result to this project. The storage tank led to the smart development of wireless monitoring system in fueling station. The project uses radio frequency to communicate with a remote data transmission. The system employs the use of ultrasonic sensor to interface with the Arduino-based microcontroller to accurate reading. The purpose of this project is the purpose of this system is to take the measurement of tank level of tank reading. Sorry, excuse me. Level of fuel in the tank. The underground fuel storage tank are commonly used in petrol stations and large industries. So the taking of the fuel gauge in this industry has resulted to various hazardous moments whereby when the level of the fluid is to be taken or observed is being exposed. So this project introduced an Arduino-based smart wireless fuel monitoring system that uses ultrasonic sensor to measure the level of the radio frequency, the level and the radio frequency modules to transmit data with wireless remote display units.
Please let us.
The problem is, in conventional method of measuring fuel system in underground towns are either manual or rely on expensive property system. These methods are efficient and prone to human error and may not provide real-time data. Sir.
Sorry to cut in. You are reading for the board for us.
Okay.
Then before, just listen. Calm down. Just calm down. Take time. Take your time. Are you clear?
Yes, sir.
Exactly.
Thank you, sir. Thank you, sir. The aims and objectives of this project is it was designed to take reading in the underground tank. That is the level of fluid in the underground tank. The objectives of this project is it was designed for fuel sensing system using ultrasonic sensor and an alarm notification to indicate when the level of the fuel is either full or empty in the tank. To transmit fuel level data using the wireless frequency module. To display real time on the data receiver. The study is limited to monitoring liquid fuels levels in either petrol or diesel tanks in static tanks. This system uses radio frequency modules for short range communication and does not include GSM or Intel integration. The hardware is built using off-shell components like Arduino and ultrasonic sensors and LCD. So the limitation of this project, while this system successfully demonstrates wireless fuel monitoring using the Arduino base and radio frequency, is limited to communication range interface sustainability of the radio frequency, partially does at 433 millihertz, can be affected by nearly high current devices such as motor pumps, fluorescent lights, inverters. This is the block diagram, the circuit diagram of the project. So it uses the battery, my Arduino-based micro controller, the sensor, and the buzzer. So when the tank is in this project, we are using a container which is 95 centimeters of height. When the level of the water is zero, you are on showing your and the orange that the container is and when it's half your right, so stop proceeding. As long as my technology was 50%, I came up with the idea of how can our library advance to form of business technology. That's what proceeded with the going to the introduction. You know that libraries play a key role in providing organized access to information about shares, especially and community engagement. Traditional library institutions often rely on labor-intensive process backed with technology which can become inefficient and error-prone as collections grow. So that's why we have to come up with the idea of being radio frequency identification-based system. So now, to address the limitation of traditional system, digitizing libraries into smart libraries. So let's so now, smart libraries will promote digitized traces, provide convenient access to information, and serve as valuable collection resources in today's digital age. Known that we are in the digital age, to digitalize our library, all the books, all the equipment in our library. So that's why I came up with this. And then key feature includes interactive
digital displays, automated sorting, retrieval system, and digital reference service with remote data. You see in your own problem. Wait, my student, do you know what is mean by a problem? Do you understand what is mean by a problem? Actually, do you understand? What is problem?
That is the problem. The problem we observe while making the project.
Literally.
What's the problem?
Problem. That's
Just a guide for you because maybe you are aspiring for degree or master's or PhD. Probably maybe what is problem statement? It's because this problem statement at PhD or master's is where you should wait before you can be able to. Because from there you develop your own project. Okay, the problem statement is that you are going to. This is RFID card, also known as OTAG. The RFID card reader scans the RFID tag and passes the information on the RFID tag to the microcontroller. And our microcontroller is what is powered with the everyday power supply. Which is what similar projects people or the startups they have? That's the digital display. That's where we are going to know the information that is communicating. That the information is scanned from the RFID tag through the RFID reader. And that's the cloud Google Sheet data sheet to know the information. You can access the information including server. So, next up. So, major components, we have the power supply, 12 volt DC battery, and voltage regulator, MSC, so it's just IC for constant 5 volt supply, microcontroller, and the features of the microcontroller is the dual core processor, Wi-Fi, Bluetooth, ample memory, various communication interface. So, connect to RFID reading and okay. So, with Wi-Fi connectivity, it communicates with the library database to retrieve and update items, information like book, availability, and due date. So, that is through the use of Wi-Fi connection. Through the use of Wi-Fi connection, we can access the information that the RFID reader, the microcontroller is trying to pass, and the school library database ends. And so their own method. And we also have the passive high frequency RF tags, RF tag reader, and other components, transistor, resistor, and that make up the next one. So now, as you can see, this is the diagram. That's the display. This is the RFID scanner, and this is the microcontroller. These are so now system integration. Integration, the RFID tags are embedded in library items to track the movement, while readers are installed as strategic points like entrance and exit. Self-service kiosks are equipped with RFID readers, and that RFID tag is integrated with the central database to maintain inventory and streamline catalog. And it says that the RFID tags are embedded in any of the library equipment. So the library equipment will now be scanned on the RFID system, which is now going to log what the information on the RFID tag to the cloud, to the library server. So principle of authentication, the RFID readers connect to your phone device to serve as a host. Yes. So the RFID tags are embedded straight after that. So while the RFID readers are installed at strategic points like entrance, you can place it at the entrance, you can place it at the exit as well. I mean the RFID reader. So next up. So now results and completion. Actually, this is the data sheet of the testing. As you can see, the book ID is there, the borrow time that the student borrowed the book, the return time, the date, the book name, student, and address. You have the full details of the student there. So let's start. So result and conclusion, yes, as
So the smart, after the RFID reader, the smart library management system has been developed by integrated and controller with other electronic service to automate tasks like book checking, checkout, and inventory, thereby minimizing manual labor and errors. Thereby what minimizing manual labor and error. And going to my reference, so my reference are based on this sir. So next sir. So thank you.
Yes, thank you very much, Mr. Matthew. That was a nice presentation. Questions from the floor? Any questions from the audience?
Well,
Go ahead.
what exactly is this application doing different from the existing library management system? Or what value are you trying to add to the existing library management system?
The value I'm trying to add is
Specifically, what is the function of
this
this
one
application?
is portable. It's portable, and then it has a what? A backup system that is the battery. So
What does it do?
Sir?
What does it do?
The application, yes, it is applicable in library.
No.
Just
Let me help you. You have this shoe.
yes, sir.
You're wearing this shoe not because of fashion. You're wearing it because it is a protective measure to protect your feet against any harmful objects, right? Then other values will now follow. So what do you want to achieve? with
Yes,
this?
okay. Yes, to digitalize equipment used in library, just to track them, how they're going out and they're coming in, the date they are received and the date that they are returned, just to track library equipment.
Books.
Yes, books. Thank you.
We have many library management applications and softwares. What makes your own application unique, different from others?
Yes, and sir, I already, because this one is one, it has a backup. It is the battery, and it can sustain more than 12 hours. And then it is portable. There's no need of fixing it in just the point. It is portable. You can come here and scan, easy scanning. So it has using scanning of the RFID tag.
What he's trying to say is that when you consider a library management system, you can have like a system, like a central-based system. The front desk, all the books that are in the library are already configured.
Let's see if it's going to be faster. Which one is this one? This is construction. This one, design and construction. You miss so many diodes. Can I just recall the diode? I saw some diode.
And I use diode,
Can we see the
Department of Electrical Engineering, Power State Polytechnic, Ilorin.
the topic of my project is the design and construction of a smart scarecrow system. So the topic of my project is the design and construction of a smart scarecrow system. It's a known fact that agriculture remains a cornerstone in the global economy, where it serves as a source of employment, food, and income for a large portion of the population. However, agricultural productivity have greatly influenced socio-economic challenges and environmental challenges. Among these challenges is the invasion of farmland by animals such as birds, goats, monkeys, and so on, where they destroy the farmland and reduce the yields, and even discourage the farmers to cultivate high-value crops. So, for centuries, farmers have started using scarecrow, a traditional method of detecting. So, the traditional method of detecting animals on farmland and chasing away animals from their farmland. It is basically a human-like figure, which is there dressed in old clothes and made of stick, and they are mounted on the ground. So the purpose of this is to create an illusion of a human presence on the farmland. So to create an illusion of human presence on the farmland in order to scare away animals and so on from the field. Unfortunately, the animals have gotten accustomed to these static appearances, and they are mute. So they just enter the farmland and just destroy the whole crops and reduce the yields for the farmers. So we started using because of this we actually ventured into using smart scarecrow system, which incorporates a technology to overcome the shortcomings of these traditional methods of scarecrow. So by the use of motion sensors, a central processing unit known as a microcontroller, and the output devices also known as all the sound module, to create an amplifying sound effect to scare away animals from the farmland. So this project introduced this traditional deterrent system coupled with modern day electronics to provide an effective tool to chase away animals from the farmland. And this innovative approach not only provide a practical tool for crop protection, but also promote the use of renewable energy in agriculture. So the problem statement is all based on the fact that these animals, they still enter the farmland, they destroy the crops even after using these traditional scarecrows. So as a result of this substantial damage caused by these animals, we decided to venture into this innovative approach, this smart scarecrow system. So the aim of this project is to design and construct a smart scarecrow system, and the objective of the project is to design it, to construct the smart scarecrow system, to incorporate a medium for charging the components of the system, also to program the system to detect the movement of animals on the farmland, and at the same time trigger our sound module known as our speaker, our amplifier to the speaker. So, and to design alarm units for producing the deterrent sound effects. So the deterrent sound effects are basically predator sounds, sound of wild animals, gunshot sounds, and so on. So the scope of the study is mainly limited to the design, to the detection of motion of animals on the field, and also the farmers. Yes, it detects anybody on the farmland, like human beings and animals also. So to trigger a sound effect to scare whatever is coming into the farmland, and also to create an alarm for the owner of the farm to know that someone is on the farmland. So the literature review, we have Khan in 2018. He worked on the limitations of this traditional system. He carried out the research on the limitations where the birds, they detect the birds, they get accustomed to these static appearances. When there is no they actually created this traditional scarecrow because the old clothes they are dressed in, as a result of no wind, they just remain static. So nothing is moving. So they feel like they have been here before, and this thing is not moving. It's just there. So they just enter the farmland and destroy the old crops. Also, that comes to Singh in 2020. He carried out a research whereby we can make use of a smart scarecrow system. Although there are limitations to his own, because if we are creating a smart ecosystem, a motion detecting system that can detect the motion of animals on the farmland and trigger a sound module, it needs a constant supply, supply of voltage, to control the medium. So there were limitations. Additionally, Olatunde in 2022 decided to introduce the use of solar panels to create a kind of renewable energy to control the whole operation of the smart ecosystem. In summary, the literature shows that the smart ecosystem provides a promising solution to crop protection for farmers. So the scope of the study is mainly, methodology. Diving into methodology, you can see our solar panel, a 12-volt and 20-watt solar panel. It takes its own supply and send it to the charge controller. Our charge controller regulates the amount of voltage entering into the battery. So from the diagram, the charge controller is connected directly to the battery, because the battery takes in the 12-volt supply from the solar panel. But charge controller cannot run all the way to the microcontroller, because the microcontroller only operates on 5-volt AC supply. It runs on 5-volt AC. So because of that, from the battery, we have to introduce a voltage regulator that will regulate this 12-volt to a stable.
Which is connected to that is where the bearing housing shaft is flange. And we have the pillow bearing housing and the ball bearing housing, which while spinning the angle of the shaft, to reduce this bearing, they transfer the force through pillow bearing to the ball bearing and the shaft, and also to the gear. So, in which it produces centrifugal force to extract the on and the design goes and configuration. The machine was designed in such a way that it is easily maintained and also it protects the cleanliness of the body, protect the cleanliness, the quality, and its efficiency to use. Be it farmers that they attended to, or those that doesn't have schooling opportunity. So it is easy to use them. And material which are food safe and unsafe was used where appropriate. The container, the hexagonal jug is still stainless steel, which helps to preserve food and helps to preserve oil from loss of quantity, and steel is not, doesn't rust. And the design machine is easy to use, it is easy to use, easy to maintain where needed. When needed, you have to add through those shafts and the gear, you only have to add grease to make it more efficiency while spinning. And the overall efficiency of the engine is to grease while maintaining its quality. So by using the extractor and adding grease to where it's supposed to be, adding it to the gear, the shaft, so it makes it more easier without holding each other while spinning, and make the work more faster. Result and discussion. This study it identified the source of honey, which is the honey being brought from the farm by the farmers. Production methods, which is by putting the honey inside the hexagonal plate, stainless plate, which is rectangular. So while coming from the farm, the honey will be in the rectangular box. So when putting it inside the hexagonal shape, the hexagonal stainless, by spinning it, we have to spin it 2 or 2 times. And within this 2 times, we are extracting 1 liter of honey. So the 1 liter of honey will be extracted within the minutes, which is 2 or 2 times. So by spinning over the 2 or 2 times, we will have extracted everything from the box. So we have to remove the box and add another one. So the box removed will be used to take back to the farm to collect honey. While the local process, so we have to squeeze it, extract the honey, and throw it through the box. The box will be used. And the locally require only extractor of local content. Yes, as I said earlier, the capacity of the filter per minute when spinning the basket is 202 times per minute. So by spinning it 202 times, you going to extract 1 liter. The extractor was designed and constructed and tested for performance evaluation. The conclusion, the locally required only extractor of filter local content. The machine was designed and fabricated in a way that it gives more efficiency, and it is very, very durable, different from the way they do it in locally. Because when they are retrieving it when they are extracting the quality must have reduced, through which they use hand, and sometimes we aren't sure if the hand is properly washed. And because when it gets to the market, the contents might have reduced, and the machine gave relative efficiency of 86% when compared to the imported extractor, and which the standard efficiency should be 85%. The production costs are easily afforded by small and medium scale enterprises. During this design, we were able to design the machine. It requires no electricity source, it's manually.
Okay, thank you so much. We appreciate your presentation. Question from the floor.
So any form of in extreme conditions, it can operate in extreme conditions like sunny days, rainy days. It is splash resistant, so there is no form of water entering to the circuit. Also, beneath the surface, beneath the compartment of the circuit, we have holes for any form of ambient heat build up in the circuit to escape from the circuit without destroying it. So, in conclusion, we successfully designed the smart control system. For our recommendation, we can make use of ultrasonic sensors to increase the range for where it detects motion. Also, we can make use of servo motors to provide a robotic arm. To contribute to the reliability of the system. We can use wireless monitoring to know what is happening in the, and we can incorporate it to the circuit to know what is happening in the farmland, to have the live view of what is happening in the farmland. Also, we have AI-based detection to incorporate cameras. Thank you very much. Okay. Thank you.
My student, you have done very well actually. A very nice project. But if you go to the block diagram, the circuit diagram, okay, I think this one. My simple question is about the address size. And a microcontroller has I think basically 3 types of signals. We have the address, address bus, data bus, and the control system. So about the address size, what is address size of the microcontroller? What is the data size of the controller? What is the amount of RAM? I think maybe this one you can get it from the specification. Yeah, do you have the specification? Those things come out in order to explain the microcontroller.
Different type of
data provided also describe the microcontroller you have used. It is so address size, so data size, and the size of RAM, the size of ROM.
Microcontroller, we don't use the 18 megabit with
not the number, I mean the size of that. What is the address size? How many lines do we have along the data? How many lines do you have?
It has 12 pins, data pins.
12?
More than 12 data pins.
Data pins. What was the address pin?
The address pin, I don't know.
You can read it from there.
Yes, although it's more than this, we just have to design. We have to design the schematic view of our own project.
Have you not included all the, or have you have not described all the pin size in your design here? Is it all the pin size here? The level of the pin, is it complete?
It's not complete. Basically, because of this circuit diagram, we had to remove some of the pins to make it look more vivid for you to understand. So the data pins, we have it's more than 12 data pins, but we just have to take for our input device, which is our sensor. You have to take various data pins.
You only need two addresses. Wait, two addresses. Because your sensors, how many are there?
Our sensors are 4.
They are 4?
Yes, sir.
So you need to wear the sensors using
two individual data pins.
Individual data and address.
So it takes a 5 volt supply. We have a pin for our input and a pin for the output on the microcontroller. So we are coded using our Arduino Uno. For our 5 volt supply, it takes a data pin of input, which is our VCC. We also have our output.
Your VCC, I think, is 12 volt.
No, it is 5 volts.
Okay, I mean the
controller cannot operate on
from the battery is 12 volt.
It's from the battery is 12 volt.
You use this adjustable
voltage regulator
in order to
reduce it to a stable 5 volt.
An output of 5 volts from the 12 volt.
Yes, thank you very much.
Okay. Who is the next person?
Okay.
Why the next person?
Yeah, the next person can just come. Why the? Okay, let me go on.
You cannot.
Let me go on. Why you just take this one? This mechanical.
Solar program. Is it a group project?
Yes.
So plants or their flat tire can be a very serious so remote and so the aim of this project, the aim of the project work is to design and implement a rechargeable air compressor for inflating tire. Objective. Aims objective of this project is to develop a portable rechargeable air compressor that can quickly inflate tire anytime, anywhere, providing a reliable backup for the motorists. In Nigeria, there are very many situations where we have this commercial driver, private drivers that has these problems along the road in a remote environment where they don't have any help to inflate their tires. So this project helps a lot. So the literature review, we have so many people who have actually worked on this project. Example is Bouncer. Bouncer worked 2018 on this project, focused on developing an automatic type inflation system designing to maintain optimal tire pressure in dynamic conditions. Dynamic conditions. Methodology. This project aim is the project aim to develop a portable air compressor provided by 12 volt battery for tire inflation. So for tire inflation, it focuses on creating a compact. I don't know what is moving this. I'm not the one pressing it. I don't know what is going on. It's actually pressing itself. I can see this guy. So creating an impact user friendly.
No, I'm the one changing it now. If you're done with
user friendly system that ensures safety. So what I mean by user friendly system, this system that we actually built It's very, very easy to operate. It's user friendly, no pollution, and it's very, very easy to operate by any person, either you are literate or an illiterate. You can easily work on it. The component use. We have the component diagram. We make use of the diode, the transformer, resistor, capacitor, the voltage regulator, the variable board for organization, jumper wire connect the component, wired indicate status. The heat sink helps to absorb the heat in all the components so that we can have a very stable and full component in the system. These are block diagram and circuit diagram. And the work, I will explain the working principle with the help of this. The working principle of the machine is very, very easy. So we have 4 diodes connected in the block rectifier form. Why did I connect in the block rectifier form? It helps to convert the AC input to DC. Because I felt like, what can we do to make this project more reliable? So I felt like, let's make the circuit in it an hybrid. What I mean by hybrid, that is, you can work on AC and DC. So using the 4 block rectifier, it helps to convert the AC right to the DC. And with the help of our capacitor, it helps to smoothen the DC voltage. What does that mean by smoothing the DC voltage? It helps to stabilize the DC voltage so that it can be pure and used for all components in it. So we have the relay, we have the transistor, we have the voltage regulator in it. So the block diagram, we have the battery unit, we have the outlet. The outlet is the hose, and the indicating unit, the charge controller, and automatic cut-off unit. And in the system charging unit it has this automatic cut-off unit, whereas whenever you charge the battery, when the battery gets to 13.8 volts, it automatically cuts itself off, even without turning off the socket or unplugging the cable. It will automatically cut itself off. And once
protected from infestation from contamination, like open sun drying and like open sun dryer. So as you know that agriculture remains the backbone of the rural economies, but poor harvesting and then especially during drying leads to massive losses. So what brought about this project is because we noticed that in times there are some seasons that we have surplus of some produce, perhaps maybe like pepper, okra, and all of that. But what actually happens then is that most farmers, they sell it at a very low price so that it will not be on the losing part at the end of the day. So we now thought of, instead of farmers selling this thing at a low price or at the end of the day, maybe like tomatoes, pepper, they now end up perishing. Why can't we devise a way that can help us dry it? But there are existing methods used in drying, like the one here, which is open sun drying. But there is a very high limitation here because open sun drying exposes our agricultural product to infestation. Sometimes the person even drying the material might just want to sit beside the material because of maybe a goat is coming, or even from some microbial attacks on the some microbial infestation on the crop itself. So we now come up develop a solar crop dryer, which is this. So the objective of the next slide. So post-harvest crop loss in Nigeria can reach up to 40% due to improper drying. So beyond that, the reason why most crops they get damaged is because of there is still a very high moisture content in those crops. And when there are high moisture content, because it fastens and hasten microbial activities and bacteria to just take some activities that will lead to damage of those crops. So traditional methods are inefficient and unhygienic and highly weather dependent. So we can see this is, for instance, this pepper is on a roasted zinc now. Even with this, without even any microbial activity, even with the contamination with this roasted zinc, and it is because of this kind of drying is what causes things like cancer and many of that. So, what is the solar crop dryer now? The solar crop dryer is a device that uses the sun energy to remove moisture from crops in a controlled and hygienic way. So, it has the solar pump dryer, there are several types of dryer. We have the electrical dryer, we have dryer that use blower fans to extract moisture. But this solar pump dryer is a kind of dryer that is energy efficient, that can help us to dry our clothes with a very low cost of energy, maybe like getting fuel and all of that stuff. So let me, please can you help me through this? So I can so charging unit, or you can see this, the different units. Thank you very much, sir. So to explain the working principle of this dryer has a drying chamber. This is the drying chamber. It has a glazing, it has a tray, and it has a chimney and a vent. So this is how the solar dryer works. The existing solar dryers, they use solar panel, but because of course we do not get solar panel, and we thought of we need to do something that can be easily accessible by even farmers that don't have high income. So we improvise glass to this place. So this is how it works. This is the sunlight. This is the glass here. So when the sunlight hits the glass, there is a plate under here that is connected to this place. So it is painted grey so that it can trap more energy. So when it hits this place, this chamber, it gets heated. So there is an air that comes in through this place. So when the air comes in and stays here, it gets heated. And when the air is heated, the density of the air becomes very, very low. Then the air is able to travel and evaporate into here. So our pepper, okra, or anything not dry is placed in this trace. So by the movement of the air to this drying chamber, it absorbs moisture from the pepper or anything that is being dried. Then this place will be open, that's the chimney. So when it absorbs the air becomes more wet, then it escapes through the chimney. So this process is continuous. So that is the air movement flow of the solar pump dryer. So
so I make a
so this is the tray, and there is one more thing about the solar dryer. Use a fiber glass. What is the essence of the fiber glass? The fiber glass is used to prevent energy loss from the solar dryer. There are other methods we can use, like maybe using sawdust. But we thought of using sawdust is very less efficient because one, and the presence of too much of it, sawdust is likely to combust, though it does not happen in much cases, but it's likely to combust. But using a fiber glass is a good insulation that prevents energy loss, so that when the drying chamber is heated, so there will not be energy lost from the through conduction from the drying chamber outside the to the environment. So this is the first steps to that I explained. So types of solar dryer. We have different types of solar dryer. We have the direct solar dryer. Crops are exposed, like the image we were showing earlier. We have the indirect solar dryer. So the indirect solar air is heated separately. Crops are not exposed. So this is a kind of indirect solar dryer. And but this kind of solar dryer is called a passive solar dryer, being that it is not using electricity. But if it is using electricity, it will be called an active solar dryer. And we have a mixed solar dryer which combines both the principle of. So the component of the solar dryer, we have the transparent solar collector, that is the glass. That is here. We have the drying chambers and the trays. We have the absorber surface. That is beneath yeah, that's the absorber surface. And we have the insulation, which is the fiberglass. So that's the main component of the solar dryer. So why solar dryer? Why do we use solar dryer? It increases the shelf life of crops. Because when crops are dried, it can be stored. For instance, if we are in the pepper season and the pepper are dried, when they are stored, we can resell it when we are not actually in the pepper season. So farmers can still have more income. So it's not that the income of farmers will be only when it is the season for their produce. Hygienic and reduce contamination. Now we can close this place. Here, for air to move in, there's still a mosquito net that prevents moving of insects and all of them. So when we close it, it is more hygienic. And for instance, with most of our Nigerian rice, the reason why we have stone in our Nigerian rice is because it is being spread on the floor. There is no any anything to curb infestation and all that. But yeah, we can assure you that the infestation percentage is very minimal. So case studies. So we looked at through some journals and that we look at farmers in Kaduna using locally built solar dryers for pepper. Some of them use just they build just an upper and a stand to dry things, and some of them they just spread it on polythene liner and all of that. Indian NGO project, women cook in Kenya. This is so best cross we can dry with this solar dryer, we can dry pepper, but it is advisable that when we want to dry pepper with it, we slice it. Though it can, we can dry it as a whole, but when we slice it, it gives it more efficiency of drying. And the economic benefit of this solar dryer is farmers earn more from quality preserved crops, so they can sell it later. It reduces reliance on firewood or diesel for drying. Using of firewood and diesel for drying can contaminate our food with highly harmful poisonous gas. Then enables value addition and export potential, encourages local value. So the conclusion, solar crop dryer presents a clean, cost-effective and practical solution for crop preservation. They address post-harvest losses and open new opportunities for value-added agriculture. So this is it. So thank you very much for that.
Thank you so much.
The sky is very cloudy.
I love your presentation.
That kind of scenario, what are you going to do?
I don't know.
So, and alternate, and that's why
this has to combine with mechanical and electrical. There's a renewable energy.
It's mechanical.
Yes, mechanical. So,
I like it.
Yes.
The way that it's very cloudy.
What's your name again?
So sorry, other group members accompanying the presenter. I just to stand up.
To monitor your own level of discharge.
You have the voltage regulator, you have the surge protector.
You are only monitoring the voltage. If it reaches more than 13.8, isn't it? 13.8 volts. I think you are in the 12 volt battery. We have 6 cells, isn't it? Because each cell there is around 2 point something, 2.2, 3 something. If you multiply by 2, you get that 13.8.
Yes, sir.
So in that kind of situation, a battery system is very complex. You are not supposed to only monitor the voltage level. You have to monitor the temperature, because while you are charging the battery, the temperature matters a lot. If it is very hot, it will be a problem. So another parameter you need to monitor besides the voltage level is the temperature. It's very, very easy. And even the amount of gas, because you are using lead acid. Lead acid, when it charges or discharges, it creates gases. Isn't it? So it's very important also to check. And you are saying the lead acid is the best. Maybe you are not current with the technology. The lithium now is the best. Don't be telling us here that the lead acid battery is the best. Maybe you are not current with.
So I'm talking about the lifespan, the life cycle.
Even in terms of advantage, in terms of size, the lithium ion battery is better than the lead acid.
Okay, sir. Thank you, sir. Thank you.
Nuhu Aliu.
I'll call you.
Nuhu Aliu Nwadan. Adewale Shedrack. Adewale Shedrack is around. Kehinde Abdurrahman. Marvelous Okafor. Marvelous Okafor. Charles Maureen.
It's printed grey color.
Grey.
Sorry? It's printed grey color.
Grey.
What? The reason why we printed this grey color is because dark colors they are less more heat than light colors. Because when we use light colors will reflect back the heat. So using dark colors will allow it to retain more heat. So when from this place.
But you're looking for more heat.
Sir?
You're looking for more heat to dry yourself.
Sorry, you said using grey color allow it to retain more heat?
Like it will allow the heat that is in place. It will not allow more of conduction. Yes.
Yeah, we have to.
And the reason why we use black color is because we use grey color because our department uses, not use it to like honor our department. We painted the grey. So our department usually use grey for their projects.
No, you would have used the flat plate itself and make use of the proper color. Black that will turn.
And the thing is, grey also is a recommended color to use, not only black, just dark colors that are not that reflecting.
Okay, so have you measured the temperature?
Yes, the thing is the average temperature this solar dryer reached was about 45 degrees Celsius to 55.
You are on, not conventional. You are on. Have you measured?
Yes.
What did you measure?
We use measuring thermometer that can help us measure the
thermometer?
Not the thermometer, I think that's the barometer.
Is it thermocouple?
Sir?
Is it thermocouple or what?
Something like that, sir.
No, you have not answered the question. Simple down.
Yes, it's outside. The remaining part of the project is outside. We only remove this to explain this. What he asked is
you explained in our presentation, but you know, this is to do with food that we consume. Yeah. And normally after drying food, you need to conduct a nutritional analysis to know whether.
This is not the part that will contain the food.
The part that will contain food is outside.
Yeah.
This is where that's going to
I understand, but after the project, you have to conduct analysis on the
You need to make it black. The plates need to be black. For it to not absorb enough energy.
When you say grey, I was tempted to believe because a grey body, like black body radiation, there's also properties of grey, but radiation. But this is convection, not radiation.
It's true convection.
Again, you use glass as the glass material.
Yes, sir.
You don't remember that glass also emits in terms of different diffusion and red. And you consider something like all this transparent plastic.
And we try to, we also, the thing is, we, from experience, we think using kind of transparent plastic at continual exposure to direct sunlight, there can be a shrinking and all of that. So that's why we thought of using glass.
You can see what happened to your class now. When you are designing, must be sustainable. And whenever you put that thing, the people will be moving around. So if anything touch that glass now, that's the end of it. I like it. Okay, we don't protect it. So you have to know that you can protect the ground, even though the rain is going in, but you need to also protect the ground. For modified.
He's composed and functioning.
Yes, I love his presentation.
Yeah.
Of course, there are alternatives to these fossil fuel powered vehicles. There's the electrical and there's the solar powered. For the electrical powered vehicles, they have limitations. Electricity is not in abundance in our country. So, not only are they expensive, but also we do not have equipped operators to handle such vehicles. Also, the solar powered vehicles, they run based on the weather. Now, in some weathers, they might not run optimally, which is why we've come up with this project. This project has clean energy, it is a green tech, it is in abundance, and it is easily affordable. This is the visual representation of what we've worked on, our project. Here, you can see the frame. It is made of steel. The frame is made of steel. Then there are the gas cylinders, the steering connector, the steering wheel, pressure gauge, and pressurized air tanks, like I've said before. This is the visual representation of what it looks like. more views of the design.
Alright, so this is how the experimental setup of the compressed air engine. The gas cylinders is the compressed air. That is where the compressed air is incorporated in the two gas cylinders that is in the image that we saw previously at the back end of the motor design. Now, you might be asking, what engine are we using? How are we using? What are we using to run this vehicle? We are using simply a Honda C775 motorcycle engine. We all know what I'm talking about. The motorcycle engine. It was modified because the conventional one that we know uses fossil fuel, but this our project is we are powering it by compressed air. So we needed to modify the engine so that it can be able to accept compressed air. Now, how did we do this? We are able to modify the camshaft. The camshaft of a normal Honda C75 motorcycle engine has only 2 lobes. And this what's the work of these lobes? It helps in the inlet and the exhaust for the combustion of the fuel. But since you're not using fuel, a fossil fuel, is going to be a challenge using the same 2 lobes because of the timing of the camshaft. But what did we do in the modification? We were able to add extra lobes to make it to be 4 lobes. Why did we do this? So that the air pressure that is sent in from the cylinder into the engine will go in freely. I don't know if you understand. We go freely into the engine without any resistance, because normally in the when there's only 2 lobes, the timing makes sure that one is closed, the other one is open. But with the 4 lobe engine, is always open for the air to flow perfectly fine without any interruption. The camshaft the fabrication of modified camshaft, just like I have said. Now we test run this at various temperatures. Now let me just explain a little. When pressurized air is sent in from the gas cylinders into the engine, you just need a little breeze. There is a little shaft that we connected to the engine. Just a little bit of it starts off the engine, and then by the time you send in as little as 3 to 5 bar of pressurized air out of the 150 that is already inside the engine, it's already inside the cylinder that is in the racing that is at the back of the vehicle. When you send in as little as 3 to 5 bar and then do a little breeze of the shaft, the motor, the engine, it starts up, and then the varying pressures, the more you increase the inflow of the pressurized air, the faster the car moves, the faster this project moves. The faster. Then when you reduce it, the inflow of air of pressurized air reduces, and the speed reduces also. All right, enhanced valve timing, improved air utilization. Just like I said, if we are to use the original 2 lobes that is in the original Honda C75, is going to when one of the lobes is open, the other one will be closed, and it will ensure wastage of gas, which we don't of pressurized air, which we don't want. We want to maximize every pressurized air that is inside the cylinder, and so that is why we modified it to 4 lobes, so that every air is going inside, and then it minimizes wastage. There is no wastage at all. Every single air is used, so we enhance the valve timing and improve the air utilization. And then one of the things that we observed was that there was a smoother operation and reduced mechanical losses. There was no breakdown because of a shortage of the air inflow because of the 4 lobes that we are used. Now, the modified camshaft significantly improves the engine efficiency, just like I said. It improves the engine efficiency, as as pressurized air is forced into the engine, the car moves and it moves fluently. There is no breakage. It moves smoothly. There is no slag or any breakage or anything. The compressed air engines hold promise for a short distance mobility. Now, if you see, there are two cylinders at the back of the motor. Each of it containing 150 bars of compressed air, and each of it has the capacity of 3 qubits. Each of it, that means it's 6 qubits. Now we test run this, and then we were able to say that it can run a short distance for this one that we unless when optimal when we further do a further work on it. Now the further work needed on scaling and system integration represents step towards fossil fuel free alternative. Just like my colleague has said, we want to eliminate the use of fossil fuel, which harms the environment, and also it is not cost effective to us, which we can all agree with. Now, optimization of camshaft design for improved performance, which we did so that there can be improved. Now, he said development of more efficient air pressure management system. Now, what do we mean by this? As the air from the cylinder is being sent into the engine, there is no recycling of the air. Now, there's no recycling of the pressurized air, but with this further research, we can apply what we call the compressor, which recycles the air, so that there is no need of easily exhaustion of the pressurized air that is in the cylinder. So that compressor, what it does is that it's as the air is sent in, and it takes in air again so that it can be used. So the only thing that we might be needing from the cylinder is the 3 to 5 bar that has been sent in so that it can easily start up the engine. Exploration of scalability and application in various industries. Now we hope that this will scale into various top industries so that and it be accepted because of its affordability and all that. Investigation of potential challenges and limitations. Now, we have not seen any possible limitations to this our project, but in further research we will be careful to make sure that there will be none. Actually, if there will be, so thank you very much. Thank you.
Me, I'm not a mechanical engineer, I'm an electrical engineer, but just simple observations. You say that so limitations here on the line.
For now, we have not seen.
But here you are telling us Honda. Your design, is it applicable to Mercedes?
Okay, so
not applicable because you have tested your own design on Honda. So it's one of the limitations. Don't simply say you don't have any.
Okay, sir. Okay, sir.
Then what I just want to understand is that in a combustion engine, I think beside air, because air is not combustible, you can't ignite by using a fire. You can't ignite air. So it means that there must be any source. I know that you are not using fossil fuel, isn't it?
Yes, sir.
That is petrol or gas or
yes, sir.
But are you using compressed gas?
It's compressed air.
Then in what is confusing me is that how can you ignite solely air? How can you ignite without a mixture of energy? For example, fuel or compressed, because it's not combustible. Air itself, solely itself, you cannot.
So that is the miracle of the no. So no, I'm still coming, sir.
Excuse me, it's not possible that we all know that air by ignition you can't make it to combust, because in the engine there must be combustion in which the air will expand. So that this, what do they call it? I'm not a mechanical engineer. So that the pistol and other things will move, isn't it? Yes. But so in your own design, you have only air. And it's very surprising for me, how can you ignite air?
Now, what really ignites it?
Because actually it's not combustion.
Yes, sir.
So it sounds very awkward to me.
All right.
Then I think secondly, if it is a compressed gas,
yes, sir.
Here in this power tree, you are supposed to take into consideration the safety implications, safety aspect of it. It's very, very important because in Malaysia now, for more than 20 years, is where I have stayed. It's more than 20 years they have been experimenting with compressed air in order to combat their own gas from petrol to compressed gas. They are now phasing it out because of what? Because as it becomes older, the risk will be very high. That's why they have that experience. That's why they are phasing it out now. So here in on the line, since if you are going to say that you are going to include compressed air, you have to look into consideration safety aspects. Because anywhere that compressed air, because of leakages in the cylinder, is not 100% tight. So the question of safety comes. So that is my. I'm not going to.
Yes, you're right. You're right. Thank you very much, sir.
Thank you very much, sir.
Okay. We have agreed to empower a vehicle to compress air. Call it pneumatic. We have hydraulic and we have pneumatic. Yes. So the problem is that from where you can compress the cylinder, which source of energy you can use to compress the cylinder. Because if you use mechanized machine compressor, you understand, using petrol to compress the cylinder. So you have a uses of energy. It's better to use petrol engine only. You understand? Because if you have a compressed air, you have a combat energy. So combating energy from this energy to this energy, you have a losses. You understand? And if you say you can use a solar, so even this is not economical. Because from solar you combat it to air, to compress it, then to apply it to engines. So, but if you have a solar and electric motor, just only from solar to battery to electric motor. So this one, this project, yes, it's very nice project, but you have a losses of power. You understand? So how can you, if you have any idea to do this without losses of power, compress the cylinders?
Alright, I think we'll incorporate that into our future researches.
The problem is from his own perspective. Remember, it's like the compressed air can work the way you described it. That's what he said. But the problem is compressing the air into the cylinder.
How do we send it into the cylinder?
We have to use source of energy to do that.
Okay.
What he's saying is that it's even more price to use that than to use petrol directly inside the car. Then the compressing the air also will require energy. So it doesn't make any more sense. It doesn't make much sense.
What you're trying to say is,
which you are now transparent into them. Remind you, there's some inefficiencies in energy conversion. You are converting from an energy source by which you use to compress the air into the cylinder. And then you are using that compressed air into the cylinder to power the motor, which is another energy transfer, which will cause another losses. So even if your project will work the way you described it, in the end, it may not make much sense because the problem is compressed air. How you get the gas into the cylinder.
I think probably we should look at this through this angle as well. Yes. The situation where the engine is compressed, compressed air starts the engine to start the engine, started the engine. Now when it started the engine, it's an engine that has double turning ends. One side is cranked with the shaft or something like that, and connected to the tires. Then the other side is connected to a compressor. Now, when the compressor generates air, probably there's a way of reversing that air, feeding that air into the source where the bottle cylinder, the compressed air in the cylinder now goes in. The cylinder there is specifically for starting the engine. Once it starts the engine, the compressor starts compressing, the recycling continues. But the challenge there, I should think they should be looking at is this is compressed air. There's moisture. They are using maybe an already existing engine without taking probably cognizance the damage the moisture will cause to the engine proper. But a situation whereby probably alloyed materials that will resist corrosion fast, resist corrosion fast, are used instead of the ordinary mild steel that is used for crankshaft and this thing. That will go a long way to probably solving their problem. Incorporating a compressor that is being spinned by the engine proper, and the air now resent back into the compressor to do the work. I think that should be the better way to do that.
Thank you very much, sir.
Thank you, sir.
From what you said, I think what they are trying to do is use pneumatic system.
No, it's purely pneumatic.
Pure. So the thing is this, pneumatic system are used in industries and in places, and where they are used is not in the kind of application as in trying to generate transmission motion, continuous transmission motion on the road. You can do it, you can use pneumatic system as they do in industries by driving some control system. Like the steel controls, they are using pneumatic system and to raise down which drive some chains. After some time, or lift some metals along the projection process. But that's not a continuous process. You just open a valve and air will be channeled into this system, and then it pushes a metal up or down so that an operation is performed. And then the valve closes again. Then another time will be given. It's not continuous.
Because it's a short distance, we don't have time for that. We don't have time to celebrate Marvelous and Maureen, thank you very much.
Big topic. I would love us to do
this
topics more.
After Aliu Miwada, see around? Nuhu Aliu Miwada, Adewale Shedrack from National, right?
Keep rotating until this goes in and comes out. And once it goes in and comes back, it touches a switch. That switch now makes the system go back and forth.
Shedrack.
Activation switch, just like a button switch. Instead of you clicking it, those motors are moving, they are watching the switches around them. They are not accommodation.
You don't have ID card?
With accommodation switches, anytime something touches it, either it is breathtaking or that it goes in. So we make them go into. Now we have a water pump, we have power station, when power bank comes in, they step power bank to the required voltage. So with your power bank down, power the system, and it doesn't continue for it. You can use it again and it's still go. Now,
what of midway God's will?
It moves. While it is moving, there are interactions. One friend telling you not come up.
Also, the lobby.
And then at the end of everything,
Can I choose?
everything is not created again. Then two-way power switch, you can use it. Either you want to use normal or you want to use automatic. Bring it forward. Now that wire, the transistor DC547 was the one that was used for water indicator. When the base of the transistor is inserted into a water and the collector and the emitter battery connected to your, whether it's your LED, then the collected part is connected to the LED. Anytime the wire comes into the water, it shows. Now, at different times, there are wires that go in and from the base of the transistor that make water. Yes.
For short distance.
This is the exact stuff in standard class stuff, which is 40 cm. Just like I said, it has a power panel. Power panel makes sure that any current that passes through it is minimized and the electric current is being taken by the system. So you can use a power bank for 2 weeks, 3 weeks, 4 weeks, not just as you use it, you can use it even more and more again, and it will not like that it will never go down. So it was power saving. So it was built in such a way it's power saving. There is no more change for electric current, there is just a motor that is moving around. It's automatic. You have to place it because it won't express until there's a call. Because let's assume you have a child close to you and your child makes it sound. There's no call and you put it that way. If you come out and dispense water and water will go. But once there is no call, it will not dispense it. It will only sense your call before it dispenses it. It's automatic. Hold up, please. Your call can also be there. Your call, if you are busy in the office, let's assume after the day, let's put a problem. You can just be at the convenience and keep the meeting. And whenever you also want to, there is a mechanical button, so that if you don't want the process of removal, you can just send it and explain it what you do, and I'll switch it off once you get to the quantity you want.
You can take the capacity of the boat is 20, which is there is a 40 cm. Assuming I'm putting it 10 cm. Because I have to put the rest of it.
Yeah, in case it contains lesser water, just use the manual and give it to the other. Or if it is after and then it is
for dispensing water, doesn't boil water.
No, that is one of the limitations. It doesn't boil water, it doesn't cool it, so it can be added for industrial. So in terms of making it up, there are no wires.
My name is
Implementation of the non-smartphone voice not AI chatbot. Non-smartphone voice prompt AI chatbot. What really happens in interaction and you can do it too. So you can produce, you don't even need to pretend to be diagram or to be diagram. You must to understand programming and confirmation from the you need to get the manual. Because when I was growing up, my dad would always say that for you to learn timing, you must make it of the analog law. So that when you come to this feature was users manufacture more natural process, supporting services, but most chats or loud voice interactive make them inaccessible to individuals impaired and slow from multitasking users. Why does it matter? 25% of users prefer voice from interaction, limited digital support for visual impaired users, existing bots are often rigid and text-only. The project is based on an AI chatbot which you talk to and it will give a reply regardless of the question. So in today's world, most users prefer most chatbots and AI will have always text. But my project deals with voice. You have to ask and it will give a response from online and it will search for the answer and give you response through the speaker. The aim of our project is to implement the non-smartphone voice prompt AI chatbot. The objective is to develop a smart AI chatbot that is interactive to human. In the sense that we talk to you as if you are communicating with your fellow human, crack jokes, do research and necessary things which you need to enhance ability for visual impaired users. Some users have eye issues and some users can't even speak, can't type and other disabilities. This project has give them access. This project are giving access to AI regardless of your disabilities as far as you have voice. To improve user satisfaction with fast and natural interactions. To improve user satisfaction with fast natural interactions. If you are typing on your phone, you won't feel the way you feel compared to interacting with your AI with voice. The tone, the volume and the rest give you a satisfaction, make you satisfied when communicating with AI. Block diagram. This is the block diagram of how the project works. It gets your voice. Any question it asks it gets your voice, send it to the remote server, an AI engine which processes the voice and convert the voice to a text, which is being sent to a ChatGPT server, which answers the question and retrieves the question back and convert it into voice for you to hear aloud. So this is the text speech to text, which converts your speech to text. This is the AI engine which processes everything that you have asked the AI, and this is your text to speech AI processor that converts your text to speech and amplify it through then speak it out through a speaker. These are the tools we use for our project. The Arduino IDE, an open source development environment tailored for embedded microcontroller programming. This is a tool which we use to program the device, making use of C++ programming language and other libraries. ChatGPT, this convert the text is sent to the AI model, which understands the context and generates a relevant and conversational response. So now the voice is being sent to a ChatGPT server, which processes the questions you ask it. Then the ChatGPT answer it and send it back to your device, which speak it out loud. Tools for schematic capture, circuit diagram, simulation, and PCB. Protos is a software which we use to design the circuit, the PCB, that's the PCB, that's the printed circuit board, which is used for the project. Implementation and methodology.
the core component of this architecture, voice input module, we made use of microphone, a I2S microphone, which you, and whenever you speak, it's recorded and stored on an SD card, which is being sent to the server. ESP32. This is a dual-core microcontroller, which is connected to the Wi-Fi that processes every information which is being sent to the microcontroller. NLP engine cloud base. Now this is the cloud base that converts your speech to text and convert the text to speech for user interaction. Speaker, voice output, play back the chatbot response using text to speech system via ESP32. The speaker now play back the voice response of the ChatGPT, the chatbot, out aloud for you to hear. Stages, set of voice recognition and synthetic module. Now, this is our ESP32. This is our microphone module. This is the speaker. Now, what this does is that the speaker, the microphone processes and sends the information to the microcontroller, which the microcontroller does everything necessary for the information to be sent to ChatGPT. Interface with AI backend. The AI backend we are making use of the ChatGPT AI. Interface creation. Now, the interface creation is the speaker which interact with humans. That's the speaker. Testing and debugging using voice delay. We use voice delay to test and debug the project. Now, the testing environment, these are the necessary tests which are being made before this project is being completed. Now, we made use of signal to noise ratio. Signal to noise ratio compare the level of the desired speech signals to the level of background noise. This is the formula which is being used using the sound level meter, which we use the sound level meter software to check the sound quality in decibel, which is being quiet room we have 30 to 40 decibel, normal room we have 50 to 60 decibel, noisy room we have greater than 70. Testing the chatbot performance under each condition, record recognition accuracy at different noise level. Quiet room, when testing it, these are the percentage of and these are the results we got from the AI when speaking to it. Quiet room 30, 38, 35 decibel, and this is the accuracy, recognition accuracy of how it recognizes our voice and to give us the response. Moderate background TV, 55 decibel, 91% accuracy. Noisy market and street, 70% decibel, 70 decibel, which give us 76%. Very noisy workshop, 85 decibel, which give us 58% accuracy. This is our graph from the test we took. These are the questions which we ask the AI, because it's a portable AI chatbot. These are the questions we ask it. What is the weather today? What is recognized? The weather, the response the AI gives to us. The weather today is mostly sunny with a heat of 32 degrees Celsius. And these are, you can read, tell me, Job, these are the response from the AI, and this AI from the ChatGPT server. But these are the AI voice response we got from the AI chatbot. Parameters, observation. These are the results. This is the result analysis. Recognition accuracy high in a quiet and fair. We used our ear to response relevance, context awareness, intelligence, speed, fast enough for real time, voice output clear and natural, cloud-based, usability in real world, effective in indoor and control, impact and future scope. Help visual impaired people interact with digital systems using voice, make hand-free tasks easier, increase productivity, can be used in school, hospital, and smart home, futures and scope, add support for many languages so more people can use it, make response more emotional and human-like, build a mobile version base for wider access. These are the challenges we went These are the challenges we face. Inaccurate voice recognition in energy settings, delay in real-time processing due to network issues and the rest. Limited offline functionality. Mainly, this project works with Wi-Fi.
Like with the combination of this, of the material used, which includes the electric motor in charge of the, which serves as engine in the motor in the machine, which helps the thing, that is placed in the shedding unit. It's placed in the shedding unit. Then from there, we have the blower in the separation unit. That is what blows the away. So I think with this, I was able to build, to design and fabricate the shedding machine and separation machine. Thank you.
Alright, thank you. One way Okay. Alright. So for me, yeah, I love the idea of
It's on my phone.
So before
this is the like on breadboard. It's only added on my phone, sir.
we have to pause because we cannot really you can demonstrate the practical aspect of what you have done. So is it coming or when is it coming? Like what?
The next 1 hour.
So if you didn't come next and finish the assessment, what happened? What happened?
No, we can step in.
So that's the reason why at times you should plan well so that they don't have this kind of issues.
It's okay. We just need to let it be at the moment.
So we leave that outside, we can go to the
when they come.
What I mean, I didn't know, sir. I would have said the letter and let us because where is okay, so anybody with any
question about that? No.
It's through the teacher review.
Which school?
So
you can do stuff out.
you can come. You can sit down while we wait for. This is number.
What's the name?
Okay,
number 5. Going back to number 5.
You finish? No, you can only do that if you have studied out. Why? Okay, if you have studied out, what is the novelty of your what is the novelty of your what other method people have done? What type of method other people have done? Just tell the person has done solve this problem using process. This is what I want to hear from you.
Okay.
Have you carried out? Have you read literature and find out those things?
Yes, sir. Actually, you give me some research.
No, actually, just simply tell me I have not done.
I'm not done.
So it's very important to go and do that. From there, you will be able to build on to find to address the limitation of the existing method, so that you can make contribution to knowledge. Because this thing, if you send it for publication, they'll be looking for novelty. This is that. They'll be looking for novelty. Something you added value of your research to the research community. And even this measurement instrument you have used, which type of measurement instrument?
We use the software to measure the sound ratio.
Yes.
And we use this software room.
No, the measuring instrument for the noise.
The software.
There's an instrument there you change.
I said it's a software we use to measure the sound. Now to measure the sound and the noise.
The question, what is has somebody done it
Yes, sir.
Which research use that method? That instrument?
Mostly the instrument or the
instrument.
Okay. So I'm not really.
Okay, this thing we are trying to get
change of load from different sources, like different power sources. We are
what is the activity? Because now if we start asking questions, all these things we can say that in order to do it properly, that's a method.
So first of all, we need to understand the components that we need to do all this. First of all, we have the Wi-Fi remote. The microcontroller is what it sounds as a motherboard and it allows the interchanging of power sources. And we also have the relay 100 amp relay module for switching of different power sources also. So we also have the manual override. The manual override is also the manual for the local so that you can control the switch manually. And we have the Wi-Fi module that you can control the switch through using your Wi-Fi. And power supply, suitable for power supply for the microcontroller and relay. That's your grid, generator, and solar.
Design.
So construction steps, we designed the PCB, we designed a printed circuit board for the microcontroller relay model and other components. We assemble the components on the PCB board. We programmed the microcontroller to control the relay model and communicate with the Wi-Fi model. The integrated Wi-Fi model is connected to the microcontroller. And the manual override. The manual override is where you can control it through manually. And then we test the system for performance. Now this is the block diagram where we have the 200 amp voltage. We also have the AC voltage converter. We also have the rotated DC power. We you can see the system on the chip, Wi-Fi microcontroller, and then we have the production lever through your outputs, 220 AC outputs.
We have a sit down and think a lot about it, how to solve it.
So tomorrow the national grid is collapsed, so the problem it causes is very high. So with this thing happening in the country, so we sit down and think about how we can generate electricity freely without affecting the climate and without affecting our ozone layer too. So we come up with this design. It's a generator which generates electricity, and through the output it's generating, it's still charging itself. So to operate, so it's giving perpetual motion. This is how it works. This is system operation flow. So our first number is battery. So from battery powers the 12 volt DC motor. And DC motor, through the coupling, it rotates the generator, our AC generator. So this is the load. And from the generator, the output we get today. So we connect our battery charger. From the output we got today, we charge back our battery. So to give perpetual motion. So this system is operating non-stop. So though the question asked before now is that what is my improvement on this? Though 2 sets have done it before me, and what we notice is that the system is not charging the battery back, and the second one, the tongue of the motor that is running the generator, it's not enough to generate enough current. So I work on that, which this system is charging the battery back through the battery charger, and the tongue is enough to feed the battery charger and some set of load. according to the capacity. Thank you.
About 10 minutes. Okay. You skipped your problem.
Go to problem statement.
Go back, let me see, go back.
So you just go to your Chrome and then you input the IP address. And once you input the IP address, this is what it's going to show you. And then we have the red phase, the yellow phase, the blue phase. And the red phase is for grid, and then the yellow phase is for generator, and the blue phase is for solar. So let's say the grid is off now, we go to solar. It's not going to come up because there's no solar power supply here. And then we go to generator. The same thing is not going to go. But once, let's say the grid is back on, just go back to the grid. And then
is it manually controlled?
Yes, you can still control manually.
Or automatic control? Eh? Is it manually controlled or automatic control? How do you set it up automatic?
On demand.
We are still working on that. We're still working on that.
For now.
Yes, sir.
In the topic, he said construction of 100 amps remote Wi-Fi manually.
Because of this one is not coming out, we are not really charging very well. But this is working on itself without needing of any sun or any sort any external source of energy. So that is it. High initial cost and complex infrastructure requirements for large scale revenue energy installation often poses battery to widespread implementation. Industries, communities, and households are burdened by operational expenses. Yes, this is very true. The amount of money we are using to fuel our generator every day, weeks, and months, year, if you calculate everything together, so it's very high. So if you have this system, the cost of manufacturing this system is not, it's very, very affordable. So if you have this system, the expenses on fuel can be used to do another thing. And sustainable reliance and economically viable solution that is not affected by fluctuation fuel market and grid instability is necessary. Otherwise, energy security persists hindering economic growth and educational advancement. It's the same thing I have said earlier. It's very economical and it's helped us move forward in life. Just because the money we are supposed to put in buying the fuel, so we are putting it in doing something else, any other thing in the household.
You are just telling us the literature on the back. We are talking about electromagnetic field, right?
Yes, sir.
Electromagnetic field induction.
Yes, sir.
Tell us the working principle. How does electromagnetic field? How do you use it? Just go to that technical aspect of it.
Okay, sir. Electromagnetic field induction work.
Go. Method use. Method. The methodology.
Yes, these are the design calculation of it. So our DC, our battery is 12 volt. The battery which is 75 amps. So our DC motor is 12 V, which is 1,500 and 1,500 RPM. Which our generator is 2 kVA, which is 2,000. So to the power that our DC consumes is 480 watts. And
the power, the tongue that roll this AC motor is 3.06 Nm, while the total current that our AC generator produces is 1,700, but it is advisable to use just 1,080 for it not to be fluctuating. So, and the battery, the hours is going to take to recharge the battery to go up. Why is it not 1.5 hours or 1.7?
What did you say you have to do?
Sure, which I just see these lights.
Can I see your resource? See, if you don't come with an ID card, I will not allow you to do it.
Components education.
And call your somebody to identify you. You don't have porter, school porter. Anybody can come and
No, where is the zonal coordinator?
Components, you have the battery, you have switch, you have DC coil, and then AC generator.
Where is it now?
No, it's okay, Continue, sir.
It's from Federal Poly. He presented during the zonal competition.
That's the zonal coordinator.
Yeah, that's what it is.
The zonal coordinator.
The zonal coordinator.
Identified it, yes. He presented during the zonal and his lecturers are also here. Yes.
Go on,
The
sir.
coronavirus students.
The next one.
This system helps us to manage our lights, help us to this lighting, and so help us lack of backup lighting, poles and safety risks during power outage. So when there is no power, this system can stand by for that help to navigate your stairs to where you are going. So classification helps in energy saving and domestic accidents. Also, it prevents you from maybe breeze, ground, or hitting your leg on the staircase. So, aim and objective to the A, to implement rechargeable lighting system. Objective to create motion sensor circuit for motion detection. To incorporate the rechargeable power system. Then to construct and assemble the prototype for functionality. Now, this block diagram, first of all, battery, charging module and charge the battery. After that, the operator, that's part of the system. And the VRI sensor, then VRI sensor power the box to navigate your state.
On and off. In order to, so
this is a good diagram. First of all, say, here is the sensor. Treble and battery, power the sensors. So once power the sensors, it will sense the signal. The now takes that signal and not transfer it to the board. The sensor sends a very low signal. So the luminance is not good signal for it to power the bulb. When it power the bulbs, then there will not be the lights.
we have a coil. So that is also, and that load is there.
So this,
if you look at this, what do you call here? This
that's
is
the sensors.
then
First
a
one
mode
from the
like
states. Once it sends from the beginning, it sends current to the box. Then
so here also there is
the
load.
states, then you
In
can
fact,
navigate to states. So
even
when you
if
are
you are
back also, the second
you are
sensor
you are charger that you are in back, you
send the current
are
to
in
the
back,
box, then
charging
you can
from
navigate
where
to
you
back
are,
down.
you are expire, sending the 200
This is the bread body, arrangement of
12 volts,
components, the battery, this is to
that is also a charge.
and the
So if this cycle continues like that, we are losing 20%, 20%, eventually this battery will run out.
If here the power is actually
it will charge, but look at it. If the charge of this battery depends on the voltage, on the power, on the voltage level of this battery. So after test time, which is charges, due to losses, this battery level, the battery level of battery.
From distance to sensor, 0.5 the depth of distance is very high system, and we stay on for you will not get 75 seconds out because you stay on for 75 seconds. So the most important then one thing is that I decided to triggers and something which can help you to solve problems. If you go to your the previous slide, I think you have already mentioned that they are trying to address the limitation of renewable energy. Can you what's that? Meters, yes. Up to 2.0 meters. Yes, it triggers LED switch on and sleep for 5 seconds. But if it's more than 0.2 seconds, it won't sense any motion. It won't sense, and it's not going to trigger the light or stay for any 5 seconds.
That's like
now.
Look at you say you are trying to address the problem of
once power, it takes only 2 seconds for it triggers LED lights.
Yeah, we know it's that a lot of contribution.
Now, number 2, the PRR average report time is 5 seconds. After 5 seconds, it will come back.
Solar energy and wind energy. You are trying to
the system red, every trigger is like from 0.1 meter to 2.
For example, now, if you are
to the detection becomes less level,
you are using
activation
in my area where you see it. We have out
seconds as we
I think
in the delay timer or
incorporated
PRR configuration.
you can be able to have
The
an
system
alternative
switching and timing are stable.
cloudy condition. You have your own wind because mostly you are on cloudy condition.
This
the wind is high.
visual testing.
So yeah, these two can try to improve your own project. If that, because you need constantly to charge that battery either using Gecko, if that power output,
the use of a PRI
solar
sensor
panel is there. If you are using it so cloudy, at that condition, the wind
while
will
the
bring
timer
high, so it means
ensure
that
the lights ensure the lights remain active for the specific.
and here you are telling me about
rechargeable battery
high
system provide a
efficient
backup power
cost
plus enhance
for example, if you
power
look at the solar power system, actually there is high initial cost. But what's the time duration you can use the solar?
Well done on the presentation. The presentation is logical. For me, I cannot see the novelty.
You find out that
in it.
Cost.
I see your presentation is logical, but I cannot see any novelty.
These are advantages and advantages.
This is not different from ordinary.
Although it is not initial, but the cost of energy per unit is a place to the lifespan. That is yes. So this statement is that some to me, actually, you have to incorporate solar, wind, and possibly a generator, fuel generator, so that you have different sources. If that's output power, you have your solar. If it's cloudy, you have the wind turbine. Even if there is no wind speed, that is cloudy, you can use your own generator to power the battery, because you need the system to be continuous. You need to power the battery continuously so that your system will continue to operate. So, sir, I think you need to incorporate renewable sources, which is trying to conduct.
At this moment, the equipment you are talking about is not easy. in the sense that compared to the conventional generator we are talking about, in terms of output, you cannot compare it. In the aspect of the battery, and even the electromagnetic, we are talking about using the generator, to have limitation compared to the present generator that we have. So you have to do research, more research in that area, and come up with smart through fashion that can outweigh or the advantage will be more compared to the current one using for ourselves. That company is not a easy company. The research you are doing is not a easy research, but you have to be well equipped before coming to
So this project, how can you go? It's against the second law of thermodynamics. Second law of thermodynamics is that you can get a free energy. Just only energy is transformed from another. Understand? For example, like a car, you can put it petrol, it's mechanical, it's chemical energy, then to convert it to mechanical energy. Run the car, you understand? Even the sunlight is energy, you convert it to electrical energy and like air use, like understand? So how do you approach it? What is the source of
This is
energy?
more like solar energy too, sir. What I'm trying to prove here is because our source is from battery. It's battery that powers the DC that rotates the AC generator, the electricity. And the current, out of the current it produces, we connected the battery charger, which charges back the battery. That's it. I'm not condemning whether solar energy system or the grid system. Yes, I charge the generator so that to produce.
Or in terms of the output, do you consider that?
Yes, sir. That is we generate the output. The total output we generate is 1,700 watts, but we make use of 1,080, just for us not to have too much fluctuation.
Sincerely, I want to commend relatively, I think this project is not there's a bit to improve on matter so much. Just that, like in your own case, the battery you use, the conversion of energy from the DC to AC,
yes, sir.
Use motor,
yes, sir.
To an alternator.
Yes, sir.
The only difference is that the consumption rate of the battery, I'm scared about this your battery. You use just one battery, 12 volts.
Yes, sir.
And the capacity of that your DC motor matters a lot. Because the rate at which you drain this battery will be very high. It's not as if at initial it drains just like the alternator in vehicles. In the case of vehicles, the car battery starts, the alternator continues, disengages from the battery and keep charging and running like that. It's not the same.
Yes, sir.
The major challenge we have here now is that while it circles, it goes around the circle. The rate at which you charge, now your battery charger, the capacity of your battery charger matters. And the rate at which you will return to charge the battery will not be commensurate to what is consuming. So when you use the word 21 hours, or 30 hours, 24 hours, like the case may be, it's not true yet. Because the rate of charging matters. If you are using this particular battery, instead, lithium battery charges faster. Do you understand? The consumption rate and the rate at which it charges is faster. So you think along that path, improve on the capacity of that battery. We are supposed to even use 24 volt battery to start that stuff so that that motor consumes a lot and it generates a lot of heat. So definitely you need fan to keep it cooling level. So I think sincerely it's a good one. Yes,
yes, sir.
The construction, definitely. So build on it. That charging unit. Then there's another thing to it. It can be a standard charge.
Yes.
You build an external charging unit. When it is not in use, you can plug to a
AC.
You keep charging the battery. What of a new are you in water? Around? What of a also, do you know
My life is
is he around? They around. Nuhu Aliu Bewada.
Now the next one, the next like when you like the energy go like they watch the place. They turn around, they see how you know, as you enter the gate, there's a real drive. Where is it? Sensor. No, they are not
We are working on staff. Now we can come and see it there.
But pricing,
Okay. So, Ajala.
this one. They are going to pay this.
No, don't worry.
That's all the HMO.
Don't worry. Thank you.
Mustafa, where is your Where is your Do test your paper outside.
We can test it.
Okay, you said it will detect, listen, so it will detect the movement, right? The movement, notify the panel again to trigger the sounder, right? Let me see how it works. Where is the coverage?
The coverage is 6 to 7 meters.
7 meters?
On every direction.
Okay.
From any direction, around 360. It works. It's a multi-directional system.
Okay. Let me see whether
it's very loud.
Very loud, so you take it outside.
You can't adjust the volume.
No. Not adjust it. You should take it outside. Let's go outside. I want to have this thing. Let me have the food. I like it. It will detect movement. And then you can find the panel. And then the panel will also okay, this man is in your palm.
Just bring it, that's it. Let's move it too small.
Yeah, let's go down.
Yes, he says 7 minutes.
Why can't you stay here? This camera, the receiver cannot go far.
So, what we aim of this project is to design and construct a portable water filtration device for emergency situation. What is the objective? To design a lightweight and effective portable water filtration device to construct an effective water filtration device, to evaluate the effectiveness of water filtration device in removing contaminants in emergency situations. Next slide. What is our significance of this study? This study strengthens the movement towards affordable, high-performance portable filtration system, driving real progress in universal access to clean water in rural areas by empowering community with smarter, scalable purification technology. It not only enhance public health but also champion sustainable living where it matters most. Next slide. Water treatment. This is our literature review about the water treatment, and this is the research by the work 2012, and according to work 2012, this is our literature review. Next slide. Now this is the local water treatment using chlorine tablet, just as what we all know in our today's world, using chlorine.
Area of coverage. There is, but it's not open. It's not open.
Fine, sir. So they are now four battery are carried. If you want current, they break the number. You know that in fact, even your house, when battery don't you come up that.
Inner.
If you have things to show off, let me see them.
Pipe through the contaminated bucket. Then when it comes, this is where it gives to the filter. This is it. Then the filter collects, like when we doing our construction, we decide to go through what is special about this. Then we decide to open to see what is inside. Because during our construction, during our defense, the lecturer in our department asked us, why are we using this filter? Why not this? And we now knew that is an activated carbon filter. Then when we went to our research, we decided to know what is inside an activated carbon cartridge. Then we discovered that it contains groundnut activated carbon. It can't be washed away. No matter how long, you can use it for 6 to 1 year. Then you look for replacement. It's this carbon.
We connect to my Wi-Fi.
I understand.
If I on it now, it will give you an great system before you know that I've already on it. So it will browse just with.
I'm fine.
So if you want to communicate with it, you tap it.
Tap to communicate.
So you just tap to communicate with and release it to now give you.
Okay, you must tap.
Yeah, it's not touch. This tab is I will tap it.
Nobody can tap.
Anybody can tap.
You must hold it.
You hold it and talk finish. Now it just browse now I'm not asking now. So after you ask anything, it will have to reply you first before you can ask it again. Okay. So now what I'm saying just now. So there's no answer for it, just answer. Or tell you that I can't understand what you are trying to think. You have to tap in, just leave it to proceed. Now,
this is our reference, and thank you very much.
Your question, sir.
Well done for the presentation. And as I always say, your presentation is logical, but there is no novelty in it. Only succeeded in constructing a water purification system. This is a ready-made substance. You bought it and you insert it there.
Where is it from?
Alexa.
So when you call the bill, what is this? Explain to me. Bring this one. How much?
It's processing process is because of AI. So it can depending on the network because it will need to search or research on it. Now convert it to text. Depending on the network speed, you can modify it very fast. Very fast. So that's how it works.
All right. Thank you very much. I'm done with you. Then who's next in it? Abraham. Kendi. Wait first. This one is just to make cause a lot of this thing. So this is your.
That's my. That is my AC.
Which one is what? Where's your output now? How can I plug a pipe from the
You can get fan.
can I get fan from this place? To power it and see how it will work. Because it's not all about on and off.
Sustain.
To give output. Are you sure?
Yes, sir.
So battery is low or what? It's working now.
Saturday. But through our research and discovery, we now noticed that the filter that you can use inside your bucket can't be accessible, except you get it from outside the country and your pocket need to be live for you to access. their kind of filter. So we now decided that, okay, what can we do with the local material we have in the market that we're able to give up, that we're able to give access to potable water. That's when we now decided to change the construction, the design, decide to do it this way, having a base, then you should be able to fit in your water filtration cartridge.
You know, there are
yeah, the big one is 120 watts, and it's not this size. It's more bigger than this size. It's more like all these doors extractor of the thing, like it's kind of like.
So you only say you only give alarms. You say no, you only do.
No, like it has the regulator that every cycle inside that is. It has this guy that I can use for years. Like everything inside, they have the heat sink, absorb the heat. It has the voltage regulator.
Okay, your only mistake is that you said it can, if it's okay to just trip up, right?
Once it's charging, like it has this auto.
No, not charging. When they're playing into this tube now, it's okay to just trip up.
No, it's not trip up. It's going to indicate
it's
like
only to indicate here, and then you engage it.
So you observe the gate and know that.
Okay, because you said if you are putting end on this in the game, strip off itself as soon as gauge or that.
No. I said when it's charging, once the charger reach 13.8 volts, it's going to strip off. So when the depth of the charge of the battery goes down, you pick up again.
Okay, when they are blowing the you have to check the gauge before
you observe the
disengage.
You observe the gauge and
okay, let me see how.
Very easy to operate. It's pump motor tire. I displayed the picture. I pump motor tire. So with seconds, it's pump the battery tire.
What about the time aspect of it? You think the other one is the nice one? Try.
This one is more unique.
Yeah, like
it's unique.
Yes, it's
So what make it very different from the one we use in the
yeah, that's portable.
Yes, the one we use in the inflating tire, the portable one, it is not efficient. The efficiency is not of like this.
No, don't say that. Don't say that.
It's not like
inflating the tire.
Yeah, it's inflating the tire, but when we talk about the regulation, like you can't have many guarantee on that. Because if you should open the component, the component inside is very, very different from this. Inside of this, we have the heatsink, we have the regulator, we have the relay, that everything that protects it, like the protection is 100. And I believe that in Nigeria, we need innovation and creativity.
I think that
so this one is locally produced. Yes. I agree with you. But that one is very effective. I have one. Don't condemn it.
I'm not condemning it.
Yes. In this case, we discovered that maintenance wise, it can easily maintain.
Yes.
Unlike that one.
That's to repair.
You may not be able to
trash it.
Trash it and get another one.
Then the second one, the durability one. This one has capacity, depends on the components used. Has capacity to stay longer.
Locally produced. What's the cost of the project? What's the cost of it?
Just 36,000. 36,000. And you use it for years.
No, please.
Your casing.
Yeah, the casing is because of hybrid power we use.
Angela, who is next, please?
But can you do smaller like this and to carry the same
I only make it bigger because of solar system. So because of the thin film, so you just plaster it on it. The thin film is not like a paper like this. So just plaster it on it. No, you don't have it first. Nothing else.
I'm from Eddie, right?
Yes, sir. What's the name you say?
Joe and Olamide. Let me see.
Sorry. This is gone.
Hope you don't push anybody from the hall because the sound noise will not jump.
We take it outside. Say close. We should take it outside.
The power supply.
Hey, that's what I ask you about it because of that time. If you are using true, you are using asking, but how do you power this? If you are using unit, if you are buying it, not how is it cost efficient? You need the generator. So
the I will say that for the petrol, this is detachable. This is detachable. You can use it, you can use it and detach it, and then it will integrate the petrol engine.
If it will cost me 10,000 just to peel 50 kg, 50 kg, right?
Yes,
And
but this one the phone you were using.
just 1,000.
This one the phone you were using.
The time is 50 kg per hour.
Okay, so you've been using your phone.
Maybe you are just
That
1,000.
If you can buy a unit of 5,000, you'll be able to use this more than twice the price. Because yes, sir. And if you buy the fuel for 5,000,
this place they are using it, you probably can bring their unit. No, I'm just saying. Nobody here now. If you plug it now.
We actually have the video.
No, if you plug it now and run down their unit, you need to plug it. Now, in school, we designed this code about how many horsepower can I just plug it. That's good, but check it. You know? So you won't know.
Yes, it's not like that. Because we actually tested it and it's working. And this is the shaft shell that makes the granite and the shell. It's actually make it cracks.
Okay, now plug it to your legacy. But don't drill legacy now. Which one is this one? Which one is for who? Okay.
You don't know the fix of the extension.
Why can't you do that directly?
Now, if they are connected to
Who wants this one? Let me see.
It's this student projects now.
It should be. This should be you. So that guy that was looking about his own project. There's one guy that is your project, right?
No, sir.
Who owns this in the library? Who owns this project?
On this plan.
It's not your own, or similar.
No, my own is water dispenser.
Water treatment.
Water dispenser.
Okay, dispenser. Okay, I heard you say water something.
Maybe it's for this one. Extension.
Current. That's what I'm saying. That how.
Remove that one now.
Let's remove that one.
Just remove the extension and plug it.
Should be you.
You have to carry this one. I'm not testing anything.
You return it back there.
It's the extension. It's the extension that they put there.
It's that his machine is moderate.
It's like to not have contract. But it doesn't have off and on.
His machine, that
You
is
don't have on and off here.
It's no switch. Actually, there was no switch that was integrated because we actually tested. But the granules we have here, they are wet granules. It's not dry. The granules we have here is wet.
So
The granite is not dry.
Okay.
Listen, you are coming to defend your projects. That's the one. What you should do first is to get dry granules. And again, get this again that you use it. Okay, now it's bringing out the output now with the shop. How to separate them?
They actually, if the granite is dry, because we actually bring the dry granite, but we have to bring so that's the issue. So, sir, so that's the issue. And
the fan supposed to blow.
If the shell is dry,
it
the fan will blow it because the shell is going
to
separate it. So the shell is separate.
Then at the other side there, a sack will be put there that the granite will be.
Okay. Who's next? Next. Ajala. Ajala, what's your name again? Abiodun. Okay, here is one that yes.
Okay, glucose. Glucometer.
Test your. Let me test on my blog.
Yeah, you have to use yourself to test it.
Because you are you.
To charge me to show it.
Okay, your own is that. The question is that the existing one and your own. What's the difference between it?
The existing one and my own is you can use this one. The existing one is as specific unique. You can use. You can't use but this one you can easily go to pharmacy and get. And the
you say you can send it to the cloud.
And the recommendation building on it. We are working on the mobile app and the cloud. So to send the data to be able to be in the database, and the doctor will be able to access it.
Your practical.
Your name is what again?
Abiodun
Opeyemi.
Abiodun.
That's number 3.
This is the pin.
Number 3.
Is that installed? Is it safe?
It's safe.
Don't be on what's up my blood?
It's okay now. Okay.
Yes, we are coming.
So don't spend more than 15 minutes.
Okay, sir.
That's good, so I have to set everything.
Last year, we'll never sleep here now. Remember?
What is no? That means my business level is high.
It's high.
How much for is correct? At your age, you have 60. Anyway, it's all right. Who else again? Nothing to show again, right? We are done.
Abiodun, right?
Let's go. Number 3. So, Nuhu, Aliu Nawada is not. Kenya Chukwu is not around. So, those that present projects, we have now for the project working like that. It's not everything flow now. So,
like this, Emmanuel, the one that did the wireless,
Number 4. No.
You know I'm OD sometimes. Wait.
This Monday of prayer means that glucose, right? This year is faster. Last year, we left here 8 o'clock, 8 p.m. Politics, they are my boss. No work. And I talk to Isaac. Then wait till this week. Bye bye.
get average.
This is the selective.
Creo que fue el juice, ¿no?
Manuel, go John.
are able to finish that of national diploma, and we call on the assessor to come up and declare the results of the winners as it stands. So, Engineer Kasim Lawal.
Thank you, my doctor. Good afternoon once again to all the participants, the project coordinators for this competition, and the organizers, both the national coordinator, the chairman of the Compodet, and indeed for all the students that participated in this competition. Before I will announce the results, I want you all to appreciate yourself, please. In fact, I'm really impressed by the presentation of your project, and I just want to encourage you all that you are all winners, and I want to encourage you that you should continue to do more research to improve on your project and subsequent projects that you might also want to go into. So, at this point, we have done the assessment. Myself, Engineer Kazim Lawan, as the Chief Assessor, and with Engineer John Bosco, we have been able to look at what was presented, evaluate it based on some areas, and we have the scores at this moment. I'll start from the first student, Folorunso Matthew, from Federal Polytechnic Ede. Yes, this project was on development and implementation of radio frequency identifier smart library system. And from the average score, the students have 75 in all, total. Please, a round of applause. The second one, we have the group of students. I Waliju Lahi Fawaz Olamilekan. The second person is Ibe Onuchuku Simon and Neris Sakin Samuel Ayomikun. They are from Federal Polytechnic Ile Oluchi. All right. Their project was on design and fabrication of honey extracting machine. From our assessment, the average score in total, we have 75. The next, we have another group of students. We have Opadila Olaleye Waliyi. Sorry, that's Adeolu Providence Ezekiel. And Abdul Fatai Aishat Asake. Both of them, they are from Federal Polytechnic Ede.
Their project title was Development of a Solar Crop Dryer. And from our assessment, the average cost for the project, we have 80.5. 80.5. The next on the list, we have Luca Ado from NU. Please, a round of applause for him, please. His project was fabrication and testing of waste oil stove. From our assessments of this work, we have cumulatively 82 average score, 82. Next on the list, we have Chime Oluchukwu from Isa Mustafa Agua Polytechnic Lafia. A round of applause. The project was on construction of a 3-position 100 amps remote Wi-Fi manually operated. His own score, after assessment, we have 73.5. The next on the list, we have Owoyemi Okoyemi from Federal Polytechnic Nasarawa. The project was on implementation of rechargeable staircase lights. The score, we have 76 here, 76. We have Peter Ebenezer from Federal Polytechnic, Nasarawa. Round of applause. His project was on water filtration system for emergency situations. The score, we have 71.5. The next, we have John Akachi Prosper from Federal Polytechnic Nekede or Nkede? Nekede, okay, this. Okay, Nekede. A round of applause, please. The project was design and fabrication of activated water dispenser. The score is, we have 81.5. 81.5. The last on this our list, we have Ngwabueze Obina and Nwosu Ebuba from Abia Polytechnic, Aba. A round of applause. The project, we have design and fabrication of melon deshelling machine for small-scale farming. The total score, we have 58. So thank you all for a work well done. And at this moment, I think I will call my. All right, from the scores, I don't know if you have the tabulation of the scores. So I will start from the third position. We have, please, when I call your name, just come outside, right? We have Opadila Olaleye Waliyi from Federal Polytechnic, Ede. Third position. Third position.
There is a mistake on the name.
No, there is a mistake.
You said it's not what?
The name you called, sir.
Yes.
There is There was a mix-up in the name.
Okay, sorry. Okay, is okay. We have Adeolu Providence Ezekiel and Abdul Fatai Aisha Asake. Sorry for that. Their name was wrongly computed on the form. So that's the total score of 80.5. 80.5. Please, a round of applause again. That's third position. So I'll call the second position now. We have John Akachi Prosper from Federal Polytechnic Nekede. Can you stand up? With total score of 81.5. And finally, for the winner of the 2025 Compodet National Students Project Competition, we have Luca Ado from New Bali Polytechnic Zaria. With a score of 82. So you can see it's very close. We have 82, the winner, we have 81.5, the second position, and we have 80.5, the first position. So please, a round of applause for all of them. Congratulations. My chairman, sir, please. So, I don't know,
they will collect their gift tomorrow at the opening ceremony of 34th Korean Assembly. So their certificate is even here. So
alright.
We can give them the certificate now. So but tomorrow.
So once again, congratulations. But my chairman, before you go, my chairman, please. So please, I want you to appreciate them one by one by give them a handshake. Then the paparazzi, will take.
Let me bring here.
Okay, all right. You are doing
Good day all. My name is Engineer Aliu Rainbow Bashir from Federal Ministry of Works, Mabushi. The results are as follows. After brainstorming, we were able to come out with these results. Ajala from Ajala Ife Oluwa from Federal Polytechnic Ile Oluji project. Ile what? Oluji, I think I'm correct, right?
Yes.
Design and implementation of rechargeable air compressor for inflation. He scored 70/100. Number 2 is a group project by Idowu Olumide Solomon and Oladipo Adams Oluwamilare from Federal Polytechnic Edo. Design and implementation of granite slicing machine, right? It's called 81/100. We have Abiodun Monday Opeyemi from Federal Polytechnic Ile Oluji, same to right. Development of an eco-friendly glucose measuring medical devices, right? He scored 58.5. Emmanuel Udo John from New Bamali Polytechnic Zaria, construction of wireless fuel level monitoring system for fuel station. He scored 53.5. Nuhu Aliu Mewada is absent. Then Komolafe Adewale Shedrack from Federal Polytechnic Nasarawa, implementation of a non-smartphone voice prompt A1 AI chat bot. He scored 59.5. Mustafa Abiodun Ahmed from Kwara State Polytechnic Ilorin, design and creation of smart scarecrow system for enhancing agricultural system. He scored 87/100. Kehinde Abraman from Federal Polytechnic Nasarawa, electromagnetic induction for fuelers. He scored 56.5. Then Uba Marvelous from Abia Polytechnics Aba, development of compressed air vehicle. He scored 57. Then Nige Godwin from Federal Poly Nikede is absent. Then also Dinobi Kenechuku, am I correct that name? From Imo Polytechnic Omuma is absent too. Is that okay? From the look of things, the result here shows that number one in the list is Mustafa Abiodun Ahmed from Kwara Polytechnic Ilorin. The second position goes this way by Idou Olamide and Oladipupo Adams. He scored 81. The third is Ajala Ife Oluwa from Federal Polytechnic Ile Oluji also, right? He scored 70/100. Chairman, I think I'm done with you.
So I think we can give them the certificate. So let's start with the first position. So what is it? I think you are taking for the next. So please help us take the. Make sure you send it to me. You send it platform. Congratulations. Second position. Congratulations. Third position. No, you can hold it. You hold it together. You do the work together. HND. Yes, Umari. First position. Congratulations. The certificate, please. Yeah. Second position. Congratulations. And third position.
We are waiting till Wednesday.
So please laugh.
Do you know?
Let us
How do you know?
that test position.
Yes, we are waiting. Wait and see.
Malam, about it.
Yes, sir.
Sorry.
Check that that is should be there.
Load on and off. So these are some of review of past work there done on it. We can see that ALCA in 2005 proposed an internet-based wireless home automation system. Media 2 examine the integration of smart meters with home automation, develop a web application that allows users to track energy and so on. Then the Ladder and et al. 2024 also designed and implemented the microcontroller-based automatic phase selector switch. Work has been done on this, but what's special about this is that to operate this, we don't need the internet. We don't need the internet to operate it. All we need is the web. We need a web application. Then I call it flexible because it can be used across different devices. You can do your control on your laptop, on your mobile phone, on your pad, and any other device where you can have a web application without the use of internet. When we talk of automation, we know it doesn't come cheap. It's very expensive. Most of these companies, automation companies, they customize their products. But this, I'm presenting something that we can use, we can get very cheaply. Now, what are the components used to achieve it? The microcontroller is an Arduino board, as I've said, an Ethernet shield. I'll talk about why we are using Ethernet shield, the relay module, and a power supply. Let me quickly go to the block diagram here so that I can, because of time. So we can see our microcontroller here. And we have a router. You can see the web application. That web application will be on our device that we want to use to control it. That's like the remote. Maybe the phone or the laptop or any other device like that. But for the microcontroller, to communicate with the Arduino, we need the Ethernet shield. The Ethernet shield receives HTTP requests via the Ethernet shield. So the Arduino board, the Arduino has 14 digital pins and 6 analog pins.
6 of the 14 digital pins are capable of PWM modulation. Now, what the Arduino sends, once it receives command from the user interface, the microcontroller sends either a high or low signal to the relay module. And how do we, now, the microcontroller takes low voltage. Our module, we can use it to control a higher voltage. We cannot we are not connecting together. So we are using an optocoupler. We're using an optocoupler as like a buffer between the microcontroller and the relay module, because the optocoupler allows us to use a low voltage to control an higher voltage. So our relay module can can have as many channels as we want, because here there's a 4-channel relay which can control 4 loads. It's still possible to expand it if we have a higher. We can even, there's even a way of connecting our microcontroller such that we can use more than one microcontroller depending on the number of loads we are supplying. So now the the optocontroller between the microcontroller and the relay module is made up of a transistor, phototransistor, not really, it's a phototransistor, circuit and LED. The LED sends, once the microcontroller sends an high voltage, the LED switches on and sends a signal to the phototransistor. This signal coming is the form of, it's like the base current, you know, our normal BJT transistor. It needs a base current to trigger it. So it's the light, because it's the light coming to it that triggers it. Therefore, we have isolated the low voltage side from the high voltage side. And in the process, we can prevent damage due to switching transients on our microcontroller. So this is the circuit diagram as tested using Pro Tools software. You can see the power supply here. We have a 12 volts adjacent, then we have a regulator to give us the 5 volts needed to power the relay, and the 12 volts for the Arduino board. The Arduino board has an inbuilt, though it's even the 5 volts that will power the board, but the Arduino board has an inbuilt voltage regulator that will supply the 5 volts to the microcontroller. So this is a channel relay, and we can see here at the output can handle up to 2000 VA, because it's just 10 amps. It can handle 10 amps. So this is the interface. You can see, once we open it, we can see which device is on, which device is off. We can turn anyone we desire on or off from the comfort of our position, whatever position we are. This relay is even good for the physically challenged. And you can be in the comfort of your sitting room or office to the room, up to within the building, up to 50 meters radius.
You have 2 more minutes, right?
Up to 50 meters radius. And if it's an open space, we can control up to 200 meters radius. So in conclusion, the microcontroller-based flexible switching device has laid the groundwork for future innovations in smartphones. That can adapt to evolving user needs. Then the recommendations. Security enhancements. We can integrate security into it. Then mobile applications can be developed for it. Then we can add advanced automation features. we can connect to the cloud so that we can control from anywhere in the world. Then the surface also can be improved. And these are references, some of the references used, and the total cost is 55,550. Thank you.
Any questions? Please, brief, relevant.
Yes, can we go back to your your block diagram? Okay, from your block diagram, I realize that you have load 1, load 2, load 3, and load 4.
Yes.
The arrows are not properly connected, so it's wrong. When you're presenting block diagram like that, the arrows are supposed to be connected to the block itself. So what the flow. And then I have a question, the internet shield.
Yes.
Is it powered by the microcontroller or it has power supply?
Oh, it's Ethernet is powered by the microcontroller.
It's okay. Thank you.
Web folder. If you go back to the literature review, that second literature review, I think you said the limitation is what? The range, isn't it?
No,
that red one.
I didn't mention range.
Look at it. Number 2.
Okay,
I guess what is something on your slide? In their paper, that is ACAR 2005 proposes what? An internet-based wireless home automation system for multifunctional devices. So this paper proposes a low-cost and flexible web-based solution, but this system has some limitations such as range and power failure. It's very good that in the literature review, actually, besides mentioning the method, you have to state the limitation which you are trying to address. But look at the other reviews. For AML, no limitation. For the next one, no limitation. They are supposed to provide limitation.
I wanted the slide to contain as much.
No, in literature review, you are supposed to provide the limitation. It's not necessary that you have to address all the limitations.
Yes.
But to me, I expect you to address this limitation. That is the issue of the range. Even here you can state this one, that is ACAR 2005. It's very old. 2005 to now, how many years? Very, very old. What is the range its own work has covered? We expect you to state that, isn't it? So that since you are addressing, after you have implemented yours, isn't it? You will improve the coverage and tell us for how long it can cover. From there we have what? You have an improvement. You have to improve the existing method can to cover so distance, but you are now you have improved it to so distance. So now if you go to the block diagram, how many loads do you have there? I think 4.
Yes.
There are 4.
How many?
Load 1,
Yes.
3, and 4.
Yes.
Go to your circuit diagram.
No.
Look how many relays do you have there?
I have 2.
So then why the contraction?
No, I've done this.
Please send your block diagram to only 2 loads.
All right, sir.
Then, another thing I observe again,
yes, sir.
From this circuit diagram, most of these components I'm seeing,
yes, sir,
they are prone to failure, haven't encountered a high current voltage. What measures do you put in place to mitigate this?
High current voltage? No.
There's high current damage this component.
On the no, I thought of optocoupler.
Where is it here? Is it there?
No, it's not.
That is when it's not reflected. So
Yeah,
it's already is not reflected. You have a few seconds left, please.
I thought of optocouplers. We do that.
Brief. You can ask. What's your block diagram? You can see that your power supply is supplying your relay module.
Yes.
For your power supply, it says 5 volts.
Yes.
5 volts.
Yes.
Supplying the relay module.
Yes.
The relay module is a transformer.
It's not, no, it's not a transformer. The power supply, see the power here.
What's their,
See the power here.
What's the voltage of the load?
Of the
load, voltage going to the load.
No, it's just to power that supply is just to power the relay. The relay
I understand. What
yes,
is the voltage?
The load.
Yes, you are switching.
So he's asking about.
Thank you very much, Engineer MD Additional. Appreciate that. Thank you very much. Next is Engineer Olorode Ibo. See around or see around. Olorumaye Isaac. Am I correct?
Yes.
Thank you. Federal Police headed, right?
Yes, sir.
And they are separate. And this coil is where between the pipe.
Okay. I'm on it now. So I want to design quantitation of spectrum analyzer, right? Number 3. Please, go ahead, please.
Good afternoon, sirs. Studying an existing protocol. I'm here this afternoon to present the project which says a spectrum analyzer, construction of a spectrum analyzer with GPS and SD card data logger. The exponential growth of the wireless communication has made the radio frequency spectrum a very invaluable, and due to the our demand for radio frequency, once wireless communication, it has bring up a more need for wireless communication due to our advance in technology and all that. A spectrum analyzer serves as a crucial tool for visualizing and evaluating the amplitude of signals across the frequency domain. Now, for my project, I incorporate a global positioning system technology into the analyzer, so that I'll be able to have the ability to tag each measurement with the location. Like when I check the frequency of when I check the signal strength of a frequency, I'll be able to tag the geographical location of the present location. Then my device is portable spectrum analyzer that is equipped with a GPS, and that is a SD card logging, so that I'll be able to, all my data will be logged, that at the end of the day I can be able to have access to all my data that I've already saved. The aim of my project is I want to design and implement a portable, low-cost spectrum analyzer that integrates a software-defined radio, a GPS module, an SD card logger with an LCD display. Now, these are my objectives. I want to design a RF signal acquisition system using an antenna. I want to integrate a GPS module for accurate location of the tracking.
Then I want to find an interface of an SD module card whereby my data will be logged in. Then I want to implement a LCD display to show the real information on the screen. Then I want to evaluate the overall performance of the system. Now, what brought about this? What brought about this system? Despite the need for affordable and mobile spectrum monitoring tools, conventional analyzer does not are designed not to portably or geospatial intelligence. Now, what I meant is most of the spectrum analyzers that are outside, they can only show the signal strength of device, whereas the data cannot be logged. Then the geolocation of the place where the signal strength is being taken will not be attached with it. Then the time, because the signal strength at this present time might be different in the next 1 hour, in the next 2 hours. Now, so my that is what brought about the design of my equipment, and it also helps to train students on how frequency analysis work in when we get to the lab, how can explain an experiment to them. Then this is my circuit diagram. My methodology, the step approach of the design. Now we have some of the equipment I use, some of the components I use. We have the Atmega 32P8 microcontroller that is operating at 60 MHz, serve as the core system. Is one that is the central processing unit of my design. Then I have my antenna that is one that is receiving the signal, that is receiving the frequency signal that is being radiated out in the free air. Then I have my GPS module. Yeah, that is the one that is telling me the GPS location of the present place where I am. Then I have my SD card module, whereby it serves as a place. It serves as a place where all my data, the time, the date, the geolocation of where I'm taking my frequency analysis, and all the data will be kept there. Then I have my power supply, 5-volt power supply, to be able to power both my antenna, my GPS module, and all my. Then this is my flow chart. I have the start. Immediately it starts, it's initialized. Then it checks if the SD card is present. After then, it reads the GPS location of where of the present location. Then it gets the latitude and longitude. Then wait for frequency. After getting that one, it gets data. Then writes to the SD card. It's after a 1 hour interval, it repeats this procedure just to log my data into in case I'm at a present location now. The data will be logged at this present moment now. If the system is still on, in the next 1 hour again, the system will still be logged. Will still be logged again about the time, the frequency, the signal strength, and all that. Then these are my outcome. The outcome of my design and implementation and testing. Now I have the RTL SDI was successfully captured with radio frequency signal in the range of 100 MHz to 1.7 GHz. Then I have my GPS location, GPS position tracker. It tracks the signal within 40 seconds of a GPS. Does not work immediately; it starts, but when we implement the system, it comes up within 40 seconds when we start the system. Then I have the SD card logging. It was successfully logged by frequency, the signal strength, the latitude, the longitude, the time stack on a CSV file. Now this is my graphic user interface of the spectrum analyzer, whereby we have the signal strength there. This is the frequency at which we are finding the signal strength or at that moment. Then we have that's the latitude and longitude of where I took this sample.
Now this is my complete system. This is my construction. This is how it looks like. Then this is my SD card login. This is the date. This is on the 12th of July 2025 and 4:16 a.m. That's the frequency whereby I log in. That at different times, if you look at different times, the signal strength differs. Then this is my latitude and my longitude. Now the performance analysis. Now the startup time before the we start needed, just within 3 hours the system will still be working for 3 hours. The system will be working perfectly fine. Then after 3 hours the system will need to be restart. Then we have the graphic design interface refresh in 1.5 seconds. Now comparison with other devices. GPS login for my device, it's okay. The SD card storage is okay. The frequency range is between 100 and 1700 megahertz. The portability is very high and the cost is less. Then we have the iOS Explorer. You can see that the GPS login, they didn't have the GPS login, they didn't have the SD card login. Then we have the key sites and all that. Now the system was fully fulfilled. The project aimed at delivering a low-cost, portable, and location-aware radio frequency monitoring solution. Now, conclusion: the project successfully demonstrates the design and implementation of a portable, cost-effective spectrum analyzer. The integration of my SDR module enables the RF signal acquisition across a wide range between 100 MHz to 1.7 GHz with my GPS, then provide a reliable location tagging with reasonable accuracy between plus or minus 5 meters. Thank you. Yes, sir.
I think this one. Yes. My question: why didn't you review this work in your literature to find the limitations?
Yes, I forgot to add into this slide. I was playing. I forgot to add.
It's better you review them. Tell us the type of the problem they have solved, the method and the solution
they have used,
and so you with that you can be able to benchmark your own results.
Thanks, sir.
Now, from your analysis,
yes, sir.
If the frequency is low,
yes, sir,
that will give you accurate results.
Yes, sir.
And if you have accurate results based on low frequency, the area of coverage will be limited. And if you increase the frequency, the accuracy will not be there. That's the challenge. How do you look into that?
Sir, we are just to get, like, I want to get, I'll just tune to a certain frequency, probably a radio station, or that will know the frequency range of, then I want to look at the frequency strength at this location. Either it is high or it is low.
If it is low?
Yes, sir.
What if it is high? What do you do?
It's just for analysis, and it's not something that I'm supposed to. Okay. Yes, I've gotten your point now. And so in such a case now, we can the frequency, we can now find the means to increase the frequency of or the frequency whereby we are looking for at the present location, since the signal is low at the location.
Now, okay, please, in my own case,
It's not a question per se, but I just want to talk to him to improve his work. Sir, you are not supposed to be personalizing when you are reporting. I want my this, it's not allowed.
Okay, sir, noted, sir.
Technical reports should be able to do that. Okay? Then, like my other has observed your review, you did not even review, you are having problem statement. If from the review that you get your problem statement is what you are going to solve. And if you say problem statement, but you are writing so many statements there, did you say problem statements? All those things you have to look at it. And sir, when you are trying to go to objective, please, objective. It's a good work. Objective, quickly. Can't go. So if you cannot go, please. The objective is supposed to tell us what and what steps you use to achieve your aim. That is just what is objective. Okay?
Yes, sir.
What you have done to achieve your aim is a very good project. You have reported it well, but you cannot do project it to my satisfaction.
We have 1 more minute.
Well done.
Question. Thank you, sir. Is that what we can take? Thank you very much. Thanks. They see around. Yusuf Abubakar Miwada from Hassan Usman Katsina Polytechnic. Yusuf Abubakar Miwada, yes. See around? Yeah. Okay. From HUK? Yeah. Number 4. Malaria detection and classification system.
Good afternoon all. I'm Yusuf Abubakar, presenting a project titled Automated System for Malaria Detection and Quantification. Okay, starting with the introduction, we all knew malaria is a major disease.
Sorry, sir.
Yeah.
Your name and your institution.
Okay, I've done that.
Yeah.
Okay, let's start from the beginning. Okay. Yusuf Abubakar, standing to present a project titled Automated System for Malaria Detection and Quantification. And okay, let's go to the next slide. Introduction. We all knew that malaria is one of the most serious common disease affecting particularly sub-Saharan Africa and tropical and subtropical regions of the world. And the global impact of it is profound. And for that purpose, its early detection and prevention is of utmost importance to actually prevent its deadly impact. Okay, we can go to the next slide. Now there are challenges with the traditional method of malaria diagnostic systems we have. Some of them like microscopy and RTDs are actually time consuming, and because they involve human subjectivity, so they are vulnerable to technicians' error. It requires personnel that are well trained because it involves judgment. So a person has to be trained well to be able to judge correctly. And it may be of limited accessibility in areas that are remote. Okay, some of them. Okay, so for us, we are using automated malaria detection system in which we develop a code that we run, and this code, what it does is automatically detect malaria-infected red blood cells we have in the body, quantify the infection rate, classify these infection types using machine learning. Okay, and key component of this system we have as the hardware part of the system as well as the software. We have digital microscope, we have computer set, as well as image processing software. In this case, we use MATLAB to do that. Okay, now let's highlight the advantages of the system we are using compared to the challenges we have shown there. Of course, the challenges there are highlighted our problem statement. Okay, now the advantages here reduces delay between diagnosis and therapy, and also there is accuracy and consistency in the system, as well as real-time transmission of the system, because we are dealing with digital system, all true. So it's transmission to even remote places is seamless because we are using digital system there. Okay, we go to the next slide. Again, the advantages continued. Actually, savings of cost because of manual labor will require a certain thing, and determines infection severity, tailored drugs based on parasite count, and then reduces drug resistance. Okay. Okay, the system workflow. I think the next slide will do better. What we do in the system operation is that we actually collect image, red blood cells image, which we actually capture using digital microscope. This image will be stored in a folder and inside MATLAB folder that we can easily collect into our code, and then we will select in the code the target image we want the algorithm to work on, and then segmentation. And this segmentation is part of the most important work of the code, in which the picture we have taken will be segmented. And this segmentation has to be done to be able to segment the image so that to clear out its own mask, as well as skeletonized edges. There are also morphological operations that are performed to be able to determine the shape of the red blood cell, because our target is to actually capture the red blood cells within the sample we are taking, the blood sample we are testing. So we will carry out the morphological operations to determine the shape of the listed. The code is actually modeled to be able to detect the red blood cell as a circular unit. So there is the flow in the code in which the cell is recognized as a circular something, a circular shape, which is also part of the morphological determination of the nature of the red blood cells. And then the infection detection. To detect the infection, what we do is actually we threshold the image. In this case, grayscale thresholding. We know grayscale from 0 to 255, so we actually threshold so that clear image will appear whitish and then darker image, and that is because the color of a malaria-infected red blood cell is actually purple or violet in color, and so it will appear darker when it is examined based on this thresholding level we are applying. And in areas where it has not been affected by the malaria infection, it will appear whitish. And so by that, we can be able to identify the areas of the cells that are affected and those that are not affected. Okay? And then the code will also quantify how much of these red blood cells are affected and produce the result in percentage. And okay, there is another aspect of the code, so not captured here. The quantification will also result in us evaluating what we have done by classifying whether the disease is affected. I mean, the cell we are talking about. The sample we are examining whether we can conclude whether it is whether infected or non-infected. And that is where the machine learning comes in. Because the machine learning in the block here is for the classification of the sample. Okay? And this is the system setup, very simple. So what we require is this portable digital microscope and system in which we run MATLAB code there. And at the heart of the operation actually is their pipeline, which is supplied by the digital code there. And so we have an image here that we will have, and that represents the sample of the blood we are trying to actually examine, determine its own infection, whether or not. Okay? Showing the image there, then that image will be captured by the digital microscope, and it will be analyzed and then run by the code, and the result will be produced and classified using machine learning. Okay, so these are some of the results, and we can see that a sample was tested and 23 cells are detected, and that is one important thing. It can also help in blood count, in that it can...
We have 2 more minutes left.
Okay, it can measure how many red blood cells are there, as we can see in this one. Okay, go to the next slide. And then it can detect the malaria parasites. We can see different colors there, and it's signifying those affected and those not affected. Okay, next slide. And you can see the quantification of the malaria as well here, in this case in percentage. So 6 out of 28 can be concluded that they are affected. Okay, and these are the classifications in which we have test images. Machine learning is about teaching the model about data that we can learn from and make judgment from a new data, that new instruction that is sent into it. In this case, we have sample images that we train the system with and allow it to make judgment about whether the cell we introduce in the system is infected or not infected. Okay, and there is judgment evaluation about precision, accuracy, and sensitivity of what we have done, using what we call confusion matrix, because we are using statistical stuff, so we will have to measure how much certain we are of what we have done. Okay, and okay, what is the novelty of the system? Okay, we can be able to use hybrid canal to capture complex morphological patterns of the cell, as well as use spectral machine to be able to classify these images and make judgment about whether they are affected with malaria or not. Okay, and you can see that this pipeline can use segmentation as well as classification to be able to make judgment of what we are doing.
Any question? Okay, thank you, the presenter. Even though I think the presentation was a bit very dull, in the sense that maybe because of the approaches you took on that. But from what you have just presented, seems to be a normal inoculation of blood samples, you know, and then the serum being assessed for maybe bacterium, malaria infection and the other, and then formation of a colony, and then morphological detection using microscope, which is a regular thing that is done in the pharmaceutical, you know, today in most healthcare organizations. So, and I'm meant to know that though I saw where you said innovation, this should be a staff innovation, you know, research. So, I've not actually seen any new thing that is added to the already existing approach towards malaria detection through morphological approaches and all that. You know, because still the samples you took there and inoculated allow them to form colonies after a period, and then determining the morphology using the colonies formed. So what is actually the new thing there that is not still the regular thing that are done in these health organizations?
Okay, sir. Thank you, sir.
Sorry,
Okay.
to add to what he says so that you will say maybe that will guide you.
Yes.
Okay, sir.
I think what can be what can create that difference is maybe in the area of accuracy and sensitivity. Is your own more sensitive or more accurate in bringing out results from the existing one that we all know in the market? So that area, if you can grow in that area for us. This one this one is more sensitive. This one is more accurate. In terms of mutations, which one? Because mutation, when there's a problem of mutation, that can lead to failure.
Yeah, very good.
So those areas, how have you been able to address it in that particular area? With that, we'll be able to now link it up that this one is the improved version of the existing one.
Okay. Okay, thanks for your questions and observations. Actually, a lot about this project introduce innovation into it to start with. There are actually many ways of testing blood, malaria. There are traditional methods we know, and there are some modern methods of detecting malaria as well. And using digital system as well as AI is one of the most newest ways of diagnosing malaria. I don't know how much common it is in our hospital nowadays using this particular system to be able to detect malaria. I really don't know how common it is in our hospital. This is one of the areas, the newest areas, the budding areas, as I know of, that a lot of researchers that are into electrical field collaborating with those in healthcare.
Sir, I understand you perfectly well. The area of accuracy now is more accurate.
Okay.
You understand? Then in terms of that's the aspect of accuracy now, and also I also talk about sensitivity. Those two areas, I want you to convince me that this machine is more sensitive and is more accurate than the existing one.
Okay, sir.
I know what you are saying, but convince me.
Okay. I understand. Okay. And in the beginning, we started with the challenges of the traditional method of malaria detection. And we say some of them require human subjectivity. And this one do not. And we know that when people make decision, that is subjected to error. Different people have different perspective on things, and it depends on their own emotional level. They are humans. Anything that requires human judgment, we know human weakness will come into it. And this one does not require that.
Muhammad Usman from HUK. Is he around?
Yes, he's around.
Okay. Last time we left is 8
Good afternoon, sirs. My name is Muhammad Usman from Hassan Usman Polytechnic, Department of Mechanical Engineering. I'm here to present our project, construction of automatic rechargeable sprayer machine. So, as a result of suffering farmers for spraying, that's why we think, how come we come with a new idea to solve the problem? Because farmers are suffering. So First of all, introduction. Automatic rechargeable solar spray machine is advanced, self-sustaining agricultural spraying design for hand-free operation and zero fault dependency. You don't need fuel for this machine because the fuel is very high cost in Nigeria, and we have some machineries, spraying machineries that use fuel and have a very high cost. And we make it different size. We have a 20 liters, we have a 50 liters, and it have a very high efficiency, and it have a solar panel that charges it, and it have a lithium-ion battery because now lithium-ion battery is most high battery and durable battery, and we have a automated diaphragm pump to deliver precise, eco-friendly spraying for pesticides, herbicides, and liquid fertilizers. So this can improve the farming and a very high efficiency. Yes, we have a system features. We design it. It has a very compact design, portable and lightweight for easy transportation and installation. And it have a high efficiency, optimized system design for maximum energy harvesting and combustion efficiency. Reliability, high quality components, and the robust design ensure reliable operation in various environments. So we have a design and durability. Frame is very light, made of aluminum, and the strap FedEx ergonomic shoulder hip support. It has a weight 4.8 kilogram when it is empty, but when you put the water 50 liters or 20 liters, it's around 24 kg. Yes. So, target users, we have a smallholders farmers, they are using it, and the gardening services and the pest control agencies in Nigeria, they can use this machine, and the government agricultural extension. Then projects innovation, solar power. This machine is powered with solar because in Nigeria we have abundant sunlight. The machine is powered by solar energy, using reliance on manual pumping or fuels, making it eco-friendly and cost-effective. Secondly, we have automated spraying. The machine automates the spraying process, reducing the manual labor and increasing efficiency, allowing farmers to cover larger areas with less effort. Then, when you switch on the machine, those only you can press the button. You don't need manual switch. It's automatically when you press, it starts spraying. And the adjustable spray nozzles. The machine has a feature an adjustable spray nozzle, enabling farmers to customize the spraying pattern and ranges with different crops types and the densities. Then continuation project innovation, precision spraying. You can spray it to the place you need. And the machine automated system ensure precise spraying, reducing waste, and minimizing the risk of overspraying or underspraying. Then increase coverage. The machine solar power from and the automated spraying system enable farmers to cover larger area quickly and efficiently, making it able for large-scale farming operation. So, continuation of project innovation comparison to manual knapsack sprayer machine. So, difference is reduce labor. This solar sprayer machine reduce labor. The automated machine reduce manual labor, freeing up farmers to focus on other tasks. Increase efficiency. The machine automate spraying system increase efficiency, allowing farmers to cover larger areas in less time. And improve accuracy. The machine precision spraying system ensure accurate application of pesticides or fertilizers, reducing waste and improving crop yields. Cost effective. The solar powered machine reduce operating costs, making it cost-effective solution for farmers. So this is the image of spray machine. You do it, and like this season, in this August, the farmers need this machine because they have a very high insecticides on farm. Okay, so this is it has a solar and it has a charging port. When you go to farm, you can charge your phone through this machine. It have 2 charging ports, and it have a cover that contains the battery and the diaphragm pump inside the 4 volts, and it have a lithium-ion battery, 10 amp. Or 20 amp, 10
You
amp.
have 2 more minutes.
Okay. So this is a picture of sprayer. So advantage. Energy autonomous solar panel maintain battery during operation. Rapid charging, 5 amp, AC charger, refill battery in 2.5 hours. Because you can use with electricity to charge this machine, not only solar, you can use electricity. And even you can form your hand with your hand. If there is no electricity, no solar, you can use your hand. We call it 3-in-1. Then 0 operating costs, no fuel, no electricity expenses, low noise. The noise is 60 dB and eco-friendly 100%. Solar battery powered, 0 emission.
A few seconds.
So then these are components that we have. Systems integration, power output configurable to meet specific power requirement. Solar panels, high efficiency monocrystalline ceiling, and the lithium battery 20 amp, and BMS charging controller.
So what is the cost of this machine?
The cost of this machine for one is 100,000.
That's cost of production.
The cost of production is 80,000. Profit is 20,000. Sell this price. And the other machines, we have a machine that uses petrol. The cost is 300,000.
Now, this one that I'm seeing.
Yes.
The shape, the design is like a normal sprayer that we
Sprayer, yeah.
Are we the same? The farmer will they still hang it?
Yes, they hang it.
If they hang it,
yes,
and they walk around in the farm with it.
Yes.
Is it not?
Yes.
They walk around, it will be in their back,
Yes.
and they walk around.
Yes.
The only difference now is they will not be pumping. Yes. They will not just, that is just all. Yes. That is just what you are trying to bring as innovation. Yes. They will not just use hand to pump like chicken now. Yes. Eh? Yes. All those people the back.
Yes, we reduce the costs of spraying because if you have this machine, you go to farm, you can spray 1 hectare, let's say in 2 hours. So the manual one, you spray it in
So, would the machine use it to walk or fly through the farm? It's not the same leg.
Yeah, the same leg.
So
but
the
same leg spray 1 hectare. Pumping.
The pressure this one goes, how far? What is the length? How far will this one go?
Yes, the energy requirement.
Yes.
Plus the manual.
Yes, the energy requirement that man is using. So we solve it. You don't need your energy to pump. You can use it.
They are pumping it.
Yes. For example, the one that have using water.
Pumping pressure now. We just spray like this. Let's just what this innovation just just let overcome.
It's not how you feel it. So,
what if?
Question again from anybody? Anyone else? Question?
I'm curious. Excuse me. I'm curious about how this is cheaper than the one that is we're pumping on. What if I want to fill my
Yes, this machine, don't compare with manual. Compare it with the one that use petrol. There is the one that put petrol and they put it in the back. Understand? They have a cost of, they have a highway and the yes, and the noise. Understand? But this one is solved, is just only we use with that rubber. That's why you see
Very good. You can see that because they have enough sun over there to use the power. And next, if the battery is fully charged, how long does it take?
Okay, if battery is fully, it has 4 hours. It can take you 4 hours. And 4 hours. 4 hours. Yes. And in 4 hours, you can spray 480 liters. Over 28 bags. Understand?
Yeah, next please.
Yeah.
We don't have time.
Please,
Right on, please.
there is a place where I say it reduces waste. I don't know how this one reduces the waste.
Waste of the liquid content.
Reduce the waste?
Yeah.
Yes, because it is automatic spraying, understand? The one, no control, is a manual one. No control, but this one, it has a very high control.
The manual has control.
Has control.
The manual has
because you must have to press it before you start spraying it.
The manual has control.
This, they have a control, but this one is more high control. Because the manual,
the nozzle, is it automatic?
It's
Has
automatic
control, or you use your manual?
no, it's automatic.
It's automatic.
It's automatic.
That's why he's talking about.
The waste system, yes. When you on the game, just spray on them. Next, please. Can I have your question? You are done?
Yes, sir.
Okay, thank you very much. Please, appreciate this. The next one. Next is Engineer Barnabas M. Bashe. Is he around?
Yes.
Okay. You know, I was in HUK. You know Gambo? You know Gambo? Gambo? My friend, I was there before we did that. I was doing some lessons. Full of scorpion and snake again. And I was what's my yes? Okay, sorry.
I'm the chairman, board of assessors, other distinguished listeners seated to the board. Good afternoon. My name is Barnabas Bashai from Isa Mustafa Boys, the First Polytechnic Lafia, and I'll be making a presentation this afternoon on design and construction of 500 liters per hour water treatment pilot plant. This is my presentation outline.
Sorry, can I see ID card? You know this face? Not really? Department mechanical?
Chemical.
Okay.
So this is my presentation outline, and then I'll go to the introduction. Portable, sir? Portable drinking water or wholesome water is water that is fit for consumption. And for any source of water, it sometimes needs to undergo certain treatments to make it wholesome or potable. So water treatment is a process that makes water safe for drinking or any intended use by removing dirt, pathogens, and other unwanted materials that might be present in the water. In the engineering sense, it's the combination of physical and chemical methods that involve the use of equipment, and then it is also carried out to make water wholesome for human consumption. While I would say a pilot plant is a small system which is operated to find out the behavior of a process before using it at a large scale. Statement of the problem. Access to clean drinking water is still a challenge in many third world countries because of the expensive nature of municipal water treatment. Also, municipal water treatment in a general sense, it's not very scalable to very small scale communities. So it makes, cumulatively, it makes providing portable drinking water to rural communities in third world countries still a challenge up till today. The aim of this project is actually to design and construct a water treatment plant of 500 liters per hour capacity. These are the objectives of the project: to investigate and select appropriate water treatment processes suitable for small-scale applications, to design and construct a modular water treatment plant with capacity of 500 liters per hour, and then promote sustainability by incorporating locally available materials and energy-efficient technologies, and then to ensure treated water complies with World Health Organization standard for potable water. Design considerations for the pilot plant is the water quality. The established parameters for water quality are adopted by many countries is the WHO standard. And then the plant is designed in such a way that it produces water that meets that specified or established quality by the WHO. Then the treatment capacity of the plant is 500 liters per hour. Operational parameters of the plant will include pressure, flow rates, chemical dosage, and then optimal performance and data collection. Water treatment, this is the overview of water treatment process. It starts from raw water, it goes through screening. Screening is to remove large suspended particles, dead leaves, decay and remains of aquatic materials, debris, stones, and other particles. Then aeration is a process where the water is brought into intimate contact with air to remove dissolved gases. Then coagulation is a process where a chemical coagulant is introduced into the water in order to cause agglomeration of microparticles that causes the agglomeration of microparticles to macroparticles. Then flocculation is a process whereby agglomerated particles settle under gravity at the bottom. Then filtration to remove other suspended particles that were not collected. And then disinfection is to remove or to kill unwanted pathogens that are present, to kill pathogens that are present in the water. Then the final process is storage, where disinfected water is stored. This is the process flow diagram for the pilot plant. To the extreme left is the raw water entering the wet well, and as it enters, it goes through the screening film, where it is screened of large particles, dead leaves, and others. Then from the wet well, there is a submersible pump that moves the water to the aerator, The aerator splashes the water to bring it into contact with air to expel dissolved gases. Then it moves to the mixer M01, where chemicals are introduced. The coagulant and the lime are introduced into the first mixer. The chemical station is above on the process flow diagram. And then from the mixer, it moves to the clarifier, where the particles that have grown from micro to macro settle under gravity and can be expelled, can be dislodged through the dislodgement valve V03. Then clear water, which is at the top, moves into the filtration unit, the filter F01, and then from the filter it moves to the mixer M02, where the disinfectant is added to disinfect the water. From the mixer 2, the water is pumped through a pump to the storage tank, and a check valve is installed in order to prevent the backflow of water from the storage tank. The materials and equipment selection for this project: for the tanks and vessels, plastics were used, and the reason for using plastic is their resistance to corrosion, the strength, the durability, and also the cost affordability of the plastic. Then for the pipes and valves, PVC was used, and reason for using PVC is because of corrosion resistance, the ease of installation and maintenance, and also the precision in control of valves. Then the pumps, thermoplastic materials and ceramic materials. The pumps are made up of thermoplastic and ceramic materials. And then the reason for choosing this kind of pumps with these materials is because of compatibility with raw water. They do not deposit any chemical issues in the water. And then also for chemical resistance. Then for the filter, a carbon filter is used. And then the reason for using a carbon filter, specific filtration requirement based on source of water. And then since there is disinfection, we do not need to bother about the micro membrane filter. And then for the frame, the setup that houses the whole plant, mild steel was used, and the reason for using mild steel was because of strength and stiffness. This is the bill of material measurement and evaluation, totaling 281,800 naira as at the time of construction of the plant. Next slide. The construction and assembling of the plant. First of all, the frame, which gives the plant, the skeleton of the plant, was constructed using mild steel. And then the locally sourced PVC and other plastics were brought into the fabrication stage. Piping and locally available materials. For the PVC piping available, local materials were used. The pumps and filters were acquired in open markets to assemble the modular plant. This is the picture of the full assembly of the plant. The diagram appears as it is in the process flow diagram. The wet well, extreme left bottom, and then the aerator at the extreme left on the top. And then between the wet well and the aerator, there is a rotameter that measures the flow rate, and then it moves to the mixer. Then from the mixer to the clarifier. For the mixer, the mixer used there is a non-mechanical mixer. It does not require electricity or any agitator to mix. So it uses a combination of waterfall and then baffles to ensure efficient mixing, thereby reducing the cost of energy. And then in the clarifier, no mechanical agitator is used in the clarifier. Inclined plates are used, and they operate on Stokes' law that says particles, solid particles in liquid or fluid systems settle faster on an inclined plate. So instead of using a conventional clarifier that will require electricity, we decided this clarifier was chosen because it requires no electricity and has also a fast settling rate. Then from the clarifier, the water moves through a valve to the filter.
You have 2 more minutes.
So these are unit operations of the plant. Move to the next slide. And then the operation and testing. During the operational stage, initial flow test show operational capacity above 500, but we are maintaining the plant at 500. Visual clarity and turbidity of the water with other total dissolved solid was greatly improved, but the challenge encountered during the testing stage was there was pressure drop and leakage, and the pressure drop was as a result of leakage between the wet well and the aerator. When that was fixed, we were able to get back the pressure, the design pressure. The innovation in this project is that it's modular design, so it's easy for transportation and maintenance. and the use of low-cost local materials, also the potential for Internet of Things-based monitoring in future versions or improvements, and then the provision of valuable data for scaling up. The benefit of the project is that it promotes access to safe and clean drinking water in rural communities, and then it also aligns with the Sustainable Development Goal number 6, which is clean water and sanitation, and supports rural development and public health. In conclusion, the 5,500 liters per hour pilot plant was designed and constructed successfully using locally sourced materials. The project demonstrates practical low-cost solution to water treatment challenges, especially providing water for rural communities, and then it's ready for testing and deployment in rural areas. So this has come to the end of my presentation. Thank you very much.
Any question? Any question?
Please go to the figure 1.
This is
figure 1.
no, forward.
Figure 1.
Figure 1, that's
Forward. This is
that's figure 1.
Where are we adding chemical here?
we are adding chemical at coagulation and at disinfection. So we add the coagulants during the coagulation, and we add the
What do you do first? Are you coagulating before you add chemical? Or you adding chemical before you coagulate?
The chemical is added at the coagulation stage.
I'm asking you, sir.
Yes, sir.
I said, do you add chemical before you coagulate, or you coagulate before you add chemical?
So if I get your question.
When you are talking about the coagulation,
Yes, sir.
you said you are settling what? The particles.
Yes, sir.
Are we?
Yes. No, flocculation is where the particles settle. Coagulation is when the chemical is introduced that causes the phenomenon of the particles to agglomerate.
What is the function of chemical?
The chemical is actually to create charges around the particles so that they can agglomerate.
So what type of chemicals are you adding?
So we are adding, for the coagulation, we're using aluminum sulfate, which is hydrated, called alum. Yes, sir. And
Stop there. Is if this particular water, your raw water,
yes, sir.
has harmful germs, how do you kill them?
So during disinfection, germs are killed.
What do you do?
So we add a disinfectant, which is sodium hypochlorite. So there are 2 stages of chemical addition process.
Any question again?
Okay, the presenter, well done.
Thank you very much.
I commend you for the project. Just like my engineer just asking you a question.
Yes, sir.
You know, I'm a practical person. I worked in the water plant for many years. And in the area of aeration there,
Yes, sir.
I know that if the turbidity of the water, the raw water coming, is too high,
Yes, sir.
and you said you are not adding chemical at the aeration site until you go to coagulation. What of it, the water content contains iron? That one will not be able to settle it.
Iron, sir.
Yes.
Like the.
We have iron, water that contains iron.
Yes, sir.
If we don't add, when you are exposing the water to oxygen, air,
Yes, sir.
you need addition of chemical there before it goes to coagulation. That's the first stage. And then number 2 question I want to ask is that the quantity of chemical that you are applying, how do you monitor it?
Thank you.
Okay. So for the second question,
the recipe that is using for the
Yes.
for the quantity of chemical to be added, so a jar test is conducted at the beginning of the process.
Yes.
So that jar test helps you to determine the amount of chemicals to add to coagulate the water.
Of course, yes. One after doing the test,
Yes.
that's what we call it turbidity test.
Yes.
You run that test, you get the
have
raw water,
2
run the
more
turbidity
minutes.
test in the lab.
Yes.
And when you get the result, you have to determine the quantity of chemical that you will now add.
Yes, sir.
Then how do you now get, what are you using to add your chemical? Do you set it at the flow rate?
Okay,
of
yes.
your pump, or
Yes.
what do you do?
Yes,
That's
sir.
the question.
Yes, so I'll determine the concentration of the chemical first, and then the flow rate. So if I know the concentration of the chemical, I know the flow rate, I'll definitely know the quantity amount.
Thank you. Okay, fine.
Sorry, sir.
Good evening, my lecturers and my.
You don't have time.
Okay. I'm a student. If you remember, I'm also working on filtration device, which you also saw then. I want to ask, this is your filtration process. What are you using? The filter you are using for the filtration process? Is it activated carbon or an honorary?
It's a fiber filter.
A fiber filter, or made by you?
No,
you have a few seconds left.
No, I said it. It was acquired. It was purchased.
Okay. Is it more effective than activated carbon?
So it depends on the application. You are in your own project, you use that as an activated carbon because you wanted to remove some dissolved solids because of the absorption activated carbon use. But I've already done coagulation, so I've removed the dissolved solids.
So can this treat heavy metal?
Can they?
Treat heavy metal?
Yes.
Thank you.
Thank you.
Next, we have Engineer Wala Jesse Dauda from the Federal Provincial. Engineer Oloyede, is he around?
The chairman, the panel of judges, senior colleagues, colleagues, good evening. I'm J.C. Daudabola from Federal Polytechnic National. I'm here to present a project titled Design and Construction of a Multi-Grain Cleaner. In the presence of foreign materials in grains, try to tend to increase maybe the volume of material if we're trying to transport. And in some process, when during post-harvest operations, we tend to clean our materials. But some of these foreign materials tend to still remain a part of our materials, on which do not only increase the bulk of the cost of handling, it also lowers the standard of the material. Then lower the standard of the material. And we know that grains and other processed material are widely used in Nigeria as our major source of food. When we use them in hospitals, IDPs, and we use them in our house. So a clean body, if we have a clean source of material, to have a clean material, it tends to contribute and increase the value of the material, and it tends to make the country to improve it in the food security. What are the problems? A clean grain is essential part of grain handling, which it improves the length of the material, increase the shelf life of the material. There are many methods in which we can clean our grains, but these methods, sometimes more especially the manual methods, tend to not provide an effective means in which we can clean our materials. Despite many programs that the government have put in different levels, our farmers, which are our targets, tend to have have not gotten the right equipment to in which they can clean their material, they still need and they still use their manual level. The aim of this work is to develop a multi-grain cleaner. The objectives are to reduce the losses of time in which we associate with manual cleaning, in which some cleaning women will pick the material and tends to use natural air to blow contaminated materials out of it. And in so doing, it's still not clean. Then another objective of this work is to reduce the amount of power consumption, the power by the consumption rate, in which it reduces drainage. And it also one of the objectives is also to increase the efficiency of cleaning. The tools used for developing of this material are devices that are usually available in our local workshops, and which include sometimes measuring scales, punchers, hammers, drilling machines, electric welding machines, vernier calipers. These are tools that are found locally. These are some of the design criteria used for designing the equipment. This is used for designing of the hopper. This one is used for determining to design the power requirements for the machine. Okay, so this is the formula that we use after constructing the machine. We use to determine our cleaning efficiency, where the cleaning efficiency 100% is GO all over GO plus GC, where N is the mu is our efficiency of the machine, which GO is the total grain or the total material we use for calculation, and then after sieving or after cleaning, the contaminated one, which is our CM. The output of the machine is calculated by using this formula. These are specific parts of the machine. The machine has a hopper in which material is being introduced into the system. It has a blower in which it blows the materials using density. Then it has a reciprocating sieve in which it's two sieves which tends to sieve our materials. Then it has a grain outlet. It has two chaff or debris outlets. Then it has a frame in which it houses the machine. It has a power system in which in the machine it uses dual power system. It can use electric motor and it can use electric motor. Then there are pulleys and loop belts. This is the schematic diagram of the machine. If you can see the machine has a hopper which is designated at 1. Then the number 2 is our reciprocating sieve. The reciprocating sieve comes in two ways. We have the rectangular sieve and we have the circular sieve. The rectangular sieves are the larger ones in which it contains or need to remove the larger materials. Then when the materials falls on the next sieve, we know that the material has debris. Like let's say for example, if we are using sesame seed, for example, after harvesting, we know the larger shaft tend to stay on top, and if you still clean it, you will discover at the bottom you will still see debris and sand. So the circular sieve tend to remove those dust materials, and in which it will come out at level 0.9. Then it has an electric motor in which we said it can be dual. We can remove the electric motor and you can replace it with a mechanical power system. This is the isometric view of the machine with all the dimensions. This is the plan view of the machine if you are looking at the machine from the top. This if you are looking at the machine from the side. The components, these are the way we couple the components of the machine. Because our targets are mostly the rural farmers in which they cannot get it from farm. So we try to use the normal fabrication welders around to fabricate. And these are how we weld our components. The first one is our frame, in which we use a 2x2 angle. The construction method we use in cutting, we use cutting machine, tapes, and engineering square. Then the method of construction we use welding. We have the hopper too when we use the welding. Then the oscillating sieves, on which we have our sieves. We have drilling and we also weld and tie. Then the fan. We also fixed it by welding. The housing too, we constructed and use it by welding. Then the power prime mover seat also use welding. This is the machine after welding. This is when the machine is fixed. You can look and see the machine. It has by the side here where the output machine is. The machine is then the other one, the first one. Okay, can I go closer? So we have to look at it. I said it has two sieves. Then at the end of the day, we have three outlets. This is the chaff outlet, this is the grain outlet, and these are the chaff dust outlet, and that is where the clean material will be received. This is when it's closer. If you look at it inside, you can see materials that was used for testing is still there. If you can look at it up, you can still see debris. This is the machine when you use.
You have 2 more minutes.
Yes, this is the machine during operation. So at the end of the day, these are some of the data collected from the machine, an average of it. We said the machine uses an average power of 2 horsepower. It has a cleaning efficiency of 86%. In conclusion, this machine is mostly designed and fabricated to meet the requirements of small-scale farmers and peasants that are some post-harvest operators. The machine is suitable and is cheaper, and it can be used and it can be introduced to farmers. Thank you.
Thank you very much. Thank you. Any question? You said multi-grain.
Yes, sir.
You can use it for maize.
No, smaller seed.
Right.
Smaller seed like Benny seed. You can use it for acha. You can use it to clean your gari. You can use it for millet. You can use it for guinea corn.
When you say clean, do you store it with the machine? Can you store with the machine?
If you
have stones.
Oh yes, if the stone size are larger than the first aperture, then the next level, that what the sand is, it will remove it. And cleaning is you can do cleaning operation multiple times in processing. So after cleaning, you can still, after the stoning, the ones that are not removed, you can use the machine to remove it.
It's 2 horsepower, right?
Yes, sir.
And with the stone in the coin now, they have the same size with stone.
Yes. Yes.
How then?
No, in this case, it cannot be stolen. Yes, because the aperture size and the stone size
have the same weight. They have the same size.
Yes, because they have the same size and the same weight. But this is one of the limitations of this machine on which we are trying to build on.
My suggestion is the fuel you use, I think, in empowering the generator. Go to the generator. The main project.
No, okay, it comes, you can use electric motor or you can use petrol engine. It's a multiple one.
But if you use electric motor, don't you think it's very expensive, the electric motor?
That is why we said the machine can be used in 2 places. You can use it in indoor when your system is fully automated.
We want you to make it affordable. That's why I'm
okay, yes. Now with the high cost of electricity, it's going to be a little bit expensive.
The problem is we are trying to prevent pollution of the environment. So it's better for you. It's better for you not to use fossil fuel in power the generator. Because yes, it's better if you have a battery, and you can charge the battery in the home. And I think that energy in the battery, you can use it in order to combat. If you use the electric motor in order to use the battery energy and convert it to rotational energy to power the machine. And secondly, I think the objective, what are the objectives there? The objective to save what? The time lost associated with manual seed cleaning process and to reduce what? Energy consumption rate and increase the cleaning efficiency. My question, have you carried out an experiment and generate data to achieve those objectives? Let us start with the first one, to save time lost. In your own result, have you carried out an experiment in which you test the time your system is using and the existing method?
Yes, the method we use is the manual method.
I'm not saying comparing, I'm thinking about
yes,
comparing.
so we compare our method with
what is the time your own system uses? The amount, the amount time used.
You know, you collect, it will take participants. It will take
because in the data I'm not seeing in your own conclusion, I'm not seeing a comparison or benchmarking about the timing of your system and the timing of the instance. Is there you compare? If your own timing is less, then you say your own is less.
Okay, sir.
And I think because if you look at your own, let us go to the result. I'm only seeing the result of your own. Look, go to the result.
Yes. My own of the machine, of this particular machine.
Yeah, well, look here. I'm only seeing the result of your own system. What is the result of the existing system? Is there you make comparison so that you prove to us that your own is better. But you have not done that.
Okay, yes. I have not
Listen,
I will
try and
let's go another question. Any question again? We have 5 seconds left. No question? Thank you very much. Right. The next is Engineer M.A. Adesina. Oh, sorry.
Good evening, everyone. I am Engineer M.A. Adesina from the Mechatronics Engineering Department, Federal Polytechnic, Nasarawa. Permit me to use this minute to tell you my condolence about the late former president. Thank you. I'm here to present the work titled Domestic Wastewater Recycling System. The reason that's a problem statement. Rising scarcity of water. Yes, when you see how this is, almost everybody are digging boreholes. That is for those that can afford it. And for those that cannot afford it, they go into buying water to use. Those that cannot still afford to buy water, they don't have choice but to drink what they have. So aside it being expensive every day to buy water and use, then also drilling boreholes just take a look at it, a minute to think. Like me, I think it every day. When I go to take a bath, I think that I go 70 meters to dig this water, beneath the earth. Then I move it to 5 meters high. Then the long run, I pour the water on my head and it goes away. So the things keep going in my mind. How do I make use of this water that is just flowing away to the soakaway? I live in a rural area. It's not a central sewage system. I live in where everybody dig his soakaway, everybody dig his bore. Or well, if you can afford it. So these are part of the problem that prompted us into doing this work. Please explain. Meaning of domestic wastewater. Water that are coming from kitchen sinks, they are domestic waste. After you use them from the kitchen sinks, they go away. Bathroom showers, like I mentioned, wash hand basins, and laundry. Aside others that you use, they are always going to waste. And in most cases, they flow to the soakaway. But although in rare cases, some people after washing clothes, they save the water to be reused later or to do one or two things. Yeah. But this work is going to address those problems. The goal is to save costs, conserve clean water, reduce sewage volumes, and minimize environmental pollution. Then the objective is to create the awareness first to people, because efforts were made to produce questionnaires which were given to people. In fact, the cost of the project was even included in the questionnaire. Can you afford to recycle water at this amount? It was the response that we got from the questionnaire that gave us the guts to go into the water. Continue, please. Key component of the recycling system. We have clean water tank. Then we have the filtration unit. That is the filtration unit. Almost everything done here is locally made. The only thing I think we bought were just some small items. But majority of the things, majority of the major components, there are things that are common among us. Filtration unit filters the water. Apart from filtration unit, there are filters along the line. The first one is the filter, while the second one is the filtration unit, comprising of locally produced filtration unit. Then we have the underground tank. Underground tank is where the water is being stored, the wastewater is being stored, then pre-treated, and then, go back. And it is sent to the, to the collection tank. Then there are pumps, and there is soakaway, and there is chlorine to clean the water in the long run. Go on. Now, this is the working principle of the system. From the clean water storage tank, it goes to the bathroom for use. Then from there, it goes to the filtration. Sorry, this arrow is supposed to come here. Sorry, please, it's an error. Yes, from the laundry, it should go to filtration, not to the groundwater tank. It's an error that it happens. Then, from the filtration, it goes to the underground disinfection tank. Before it gets to the underground disinfection tank, it has passed through two types of filtration. The first one are the sieves, the filters. At each of the inspector chamber, we have removable filters. Filters that are being inserted that you can remove and replace, or remove and clean and replace. After then, it goes to, after all the work, the filtration has taken place, it goes to the filtration system, where you have gravels, coarse sand, activated carbon, and clean sand, and then filter to filter the water before it goes into the underground tank. In the underground tank now, chlorine is being added. Major calculated amount of chlorine is being added, and then it is being to destroy the germs to that extent. After then, the water is pumped to the grey water collection tank. That tank is about 3 meter height. There are three tanks in the system. The first one, the clean water tank. The second one is the collection tank, and the last one is the grey water collection tank. From the grey water collection tank now, from the collection tank now, it goes to only flush the toilets. Yes. It goes to only flush the toilet. It is from, after it has flushed the toilet now, that it goes straight to the soakaway. Then the control system. The system must have a way of checkmating the system, because if not,
there could be damage to the pump, or there could be overflow of water. The method used for now is the mechanical method of controlling the water. You just have these floaters, these float bars is attached. I think it's a common thing that we know how it works when the water is filled up. Okay, and then that indication that it's hitting the top sends signal to the sensor, and the sensor is being connected to the pump. Tells the pump stop pumping water, stop pumping the water until when the water gets to a particular level again. The pump hits again another button there, and then tells the pump please pump more water. So that's how it works. Then bacterial tests were carried out on the water that was used to wash the toilet. The water looks clean after all those filtration, but it is not for usage any longer. You cannot use it for other domestic things. You can only use it to flush toilet as far as this work is concerned. The water is tested, and there are the results from the chemical labs to tell you that the water is okay for flushing toilets. Please next slide. The challenges, initial cost is high, it's about 450,000 to install it. Then the public acceptance, a lot of people, at least the first challenge we had to convince were women, because they felt the water would be dirty, too dirty to use, especially for children and for women running away from infection and this and that. The regular maintenance is needed. Someone that is not good in maintenance cannot use it because the filters, the initial filters in the beginning that is coming up from the manifolds can get clogged. If not properly maintained, there could be a lot of challenge. Then this is a bill of quantity. I told you it's about 434, about 450,000. This is conclusion. It saves up to a lot of amount of money by using this method because 70% of the water we are using is safe. Imagine if you are spending 100,000 on water bill in a year, this guy will save you up to 70,000 out of that 100,000. You have about 30,000 only to use on to buy water or to pay for water bill.
You have 2 more minutes.
Conclusion. Okay, go on please. Recommendation. Future work. We are trying to improve the method so that by the time it is being adopted, because of the number that it will be done, improvement will come in to make it cheaper. Because for now, to me, it's still expensive. Then these are the diagram, the mechanical system showing how water is being connected, the whole water system, the one that is coming from the house, first from the normal kitchen use, after use from the domestic, goes to the groundwater tank, then it is pumped to the medium pump, then it is recycled back to the toilet. You can see each of the toilets has two piston chambers. One is for the clean water, the other is for the wastewater after it has flushed the toilet. That's the one that goes straight to the sockaway. Please go on. Go on. Okay. This is a 3D view of the whole thing. Go on. This is a more closer diagram to show how the system is. And these are the side views.
You have a few seconds left.
No. Thank you for this. Thank you.
Well, let me, do you combine waste, storm, and then solid water together?
No.
Okay, waste.
Yes.
It's on its own. Then, sorry, solid waste. On its
Yes,
own.
yes,
Then
yes.
storm, and then
From
bedroom and the rest together.
yes, they have their own channel, yes.
Okay, you only filter
The one from bathroom, yes. The one from bathroom, yes.
No solid waste.
No. Okay. Solid waste goes straight.
Look away. That one again is.
It is the one that is recycled from the waste that's used in flushing toilets that becomes the solid waste. I don't know if you get me that.
No,
now let me explain it practically. When the fresh water comes from the upper tank,
yes.
Clean water tank. Those water goes for your laundry, bathroom, and any other thing that you can use in the house, your kitchen, all of them. Those water are being recycled and stored in another tank. It is from that tank now that the water goes back to flush toilet. From the toilet, it goes to the surface. Yes, sir.
Let us go to the beginning of the slide. Is it the introduction, something like that? Okay, so I think there is somewhere he quoted, I think it is the introduction, he quoted 80%,
yes.
like that.
Yes. Next slide. Yes, yeah.
Sir, what I'm trying to ask you, this 80%, is it your own opinion or is from the literature you obtained?
Yes, from literature.
Why didn't you put the literature? Huh?
It's in the main write-up.
And I'm suggesting, because I think you have said that you are using mechanical control, but why is that? Okay, switching. Why is the diagram why that is mechanical?
It's just float back.
Just show the flow.
I just showed the float
I
back.
don't know that. Look, okay. That's one, that, okay, this
Yes.
one.
This one.
I don't understand this mechanical control. What is that?
Okay, so let me explain it to you the way it is generally. Now, you know, in your toilet, what's the name? Because WC, yes, that WC mechanism. You know, after you finish, you are done with your defecation, you press the button, isn't it? When you press the button, it's quite, if you listen carefully, you hear water rushing into the tank.
Exactly.
At some point, you don't stop the water stops by itself.
Yes.
This is the guy that does this.
Okay.
What it does it has a kind of a valve that floats in. When it sinks down, it opens the valve, allow water to flow in. As the water is filling up, it's lifting that float, that ball. That is a vacuum. That red color is a vacuum ball.
Okay.
Because of the vacuum it created, it is light. So the water is lifting the ball. As it is lifting the ball, the handle is closing gradually.
Okay.
When it gets to the top, it closes the water. Water stops.
It's working perfectly, I know.
Yes, sir.
But I would suggest to you to change this mechanical control to electrical control because it's faster. That one is a bit, you have made an improvement. If you can be able to change this mechanical control to electrical control.
Yes, sir. Isn't there a recommendation?
Yes, it will be it's a gap there.
Yes,
you have made an improvement.
Yes, sir.
Because you can tell me that now the existing methods are using this mechanical control.
Yes, sir.
Which if you compare to electrical control, the electrical control is faster.
It's better.
So if you can devise an electrical way of controlling, you can publish a paper on that. This small gap you are seeing, you can publish it.
If it's improving next, you let me know. I'm designing. 2 seconds.
So you hold this
And
Wait first.
okay. And the cost, I think there are limitations. I think there all the challenges at the end there. Please try and address those challenges so that you can make another paper.
Thank you, sir, for giving me the audience. And I want to congratulate the presenter. This is a very beautiful project, actually. But what is the viability or the sustainability of this project? How can you convince me that I should install this in my house, considering the cost of putting this project on ground? Because when we consider the plumbing work and just to flush the toilet, all this thing that you have said is just to use the recycled water to flush the toilet. So how can you convince, after this project is done, how can you convince people to actually go for your project?
Thank you very much. Like I said before, maybe you live in an area where you don't buy water per gallon. In my area, I buy 500 naira for 20 liters. Out of that 500 naira, majority of what I use is to bath, just to bath. Then another 500 naira to flush toilet. With this guy work, 30% of that money, of 500 naira, will be what I will be buying water with every day. So I've saved up to more than 300,000 to buy water. Yes, and then the viability is that as long as your plumbing system lasts, this guy lasts because you are using the same thing, you are using the same pump to pump your water. Just 0.25 pump. Later and explain.
That's a good one from Sports Campbell driver. Samuel Wally, is he around? Is he around? Samuel Wally. Engineer Odu Elendu. Engineer Ijeoma Rachel. Gideon Jonathan. Ernest Nagi. Are they around? No. Absent. Then Engineer Odu, is he around? Absent.
We are making arrangements.
Please, if you have anything to show us outside, let's go, please. We don't have time.
Yeah.
Hey! Wow.
Thank you very much.
Barnabas, what down here again?
Yes,
Is it working?
Yes.
Are you sure it's working?
Yes.
So not walk. No walk.
So how do we bring this in here? How do we bring this?
So we transported it.
How? Hilux?
Yes. But then in the course of the transportation, we had this mishap that affected.
I know.
So this arm is broken. So I just have to do an
One time you go oh, let me see. Let me see. What is water? You have water here?
Couldn't get water to fetch to fill up this container. So this is the wet well. There's a submersible pump inside. The thing is connected. So we bought the head. We bought the head, but we had to remove it because it wasn't compatible with it. So you can get the sound.
Yeah. It's working now?
Yes, the pump, the submersible pump is working, but there's no water inside. There's another pump there.
No water inside?
Why? Why don't you?
No, I want to see it working.
Okay, so we can,
If you know it's working. Look for water and then
Alright,
water is there now.
Water is here. But I can, just a clarifier. So the arrangement was in such a way that we don't need to use pump to move water from the units. It just flows under gravity from here. When it aerates here, it can just come on its own. So this is a waterfall that helps the mixing. So as the water is falling, it's mixing the chemical. It fills up here and then it falls through this.
This one, osmosis.
Osmosis. Yes. So osmosis is moving the water through a membrane. So I don't know how you want me to relate this and osmosis.
But then two different
So for the mixer, so when the water fills up this place, it falls over here. So instead of using a mixer, powering it with electricity, we have removed the use of electricity. So we're saving electricity. So when it comes here, the plates help the particle to settle. And then when we have a lot of settled particles, we can dislodge. There's a valve here, so we dislodge. Yes, and it comes down to the filter. And as soon as it gets to the filter, so instead of installing another mixer to mix the disinfectant, we just introduce it directly into the pump. Okay. So as the centrifugal pump is pushing, lifting the water up, it mixes it automatically for us. So we have reduced the cost of installing electrical equipment across the unit operations to limiting our use of electricity to just 2 pumps, pumps 1 and 2. That's all. So this design is such a way we can have extension, we can expand the storage facility.
What is Barnabas, right?
Yes, it's Barnabas, chemical engineer.
Barnabas.
Yes.
The coagulant.
We had the coagulant here. Yes. The chemicals, there's a chemical station, just like that chemical station.
So you can add it there.
Who else again, please, to ask something?
I'm here.
So we'll get a little water.
Which one? Is it MD or MA? Which one? MD.
MA.
MA, sorry.
Yes, I'm here.
We have MD. Okay, so I'll call you back.
So come and see it. Then I'll get water. Can we start the demonstration?
Okay, go ahead, close power.
Yes.
Close power, right? For multi-grain cleaner. Because of pollution. Because of your hand, please. Because of pollution. Oh, let me see the noise. For the noise, take it outside. Remove it small outside, please. Stop the noise.
The empty is here.
So before, I'm the one. Sorry, please. MD additional, the one that provides indication of what? Load speed device.
Yes.
Okay, this is a load speed device.
Yes, this represents one load, this represents another load. The load could be anything. So my mobile data is off now, and I can still power it. There's lights on, sockets on. There's the phone charging. I can still switch it off. Sockets off. If I move outside this building, I can still control it.
What's the coverage?
50 meters within 15 meters radius within a building, and 200 meters.
What is the name of the project you say?
Flexible microcontroller based flexible switching device.
Okay. Next, please. Outside. MD.
Oh, MA.
So you're not only for travel This one is okay. This is your own. MA is the one that filtration of.
Yes, recycling.
Recycling. Wastewater.
The last.
Wastewater.
Yes, sir.
Wastewater.
Yes.
Treatment water. They're the same thing.
Recycling. No, this one is recycling. Recycling. That one is treatment.
When I have waste to use for the toilet, right?
Yes.
Okay.
The last one.
This one is not portable.
Okay.
Yes, recycling.
Okay.
Okay, yes, this is from here. Go down. Supply the house. The blue line. Supply the houses. Toilet. The toilet is here. Yeah, the toilet. Then the laundry is here. That's the water that's supplying it. Then from there, it goes again.
Okay, before I build my house now, I must call you for networking first.
No. Naturally, no. Anytime you are doing building house, before you start building, you must consult mechanical for mechanical. So it is that mechanical design that is incorporated. Yes. Mechanical. That's very important. The water goes there, it shows out into this tank. From this tank now.
Number 8, out of empty. Empty addition, what is the zone? What of Isaac from Eden? 10 minutes. When you're done, let me know then, because we don't have time for that. Let's go.
That's all.
That's all.
It is absent. Absent. It is absent.
Larry. Number one. Also absent.
Now check this absent. This empty additional. Is that switch device? Significant of the project. It is as unique. Yeah, that is empty additional.
Where is that?
They have done it now. What I use phone to now activate to on the lights that time.
Oh, yes.
Yes. And again, this Isaac, second one, okay, this one is already yet. Then use Silver Card, in Wada. The man that but that really, that malaria is very good. Okay. It's very good. Yeah, it's very good. How the caliber is working. It's a very good project. Then you have brain. Mama, this man, the soluble person, is he working? Very effective. Barnabas. That's she. What meant
is that okay?
Well,
not yet activated?
Cleaning machine.
Not yet.
That cleaning machine, because you like the machine, that cleaning machine, what you bring is not.
That's done now. It needs a free space to.
I think that's how you come there.
Okay.
The cleaning machine, what is the name of it? That's the cleaning machine. Even the grain, the mesh, and they give the power, it throws power. And to remove the mesh, the power. Because they won't have to throw it on the expensive. What they need to do and use digital on the ground. To get job. And they say, oh, but that's what it is. And again, some is committed. Now put the stone. This waste you can done with the waste. The waste. Benefit, okay, benefit. Oh, yes, that's what it was going. Oh, yes, benefit 25. Benefit. Yeah, we try. Let's pray. It's working.
So we add now, right? It's absent.
Certificate of participation. I told him now. Engineer Barnabas. Yes, sir. Mohammed Usman. Mohammed Usman. Yes, sir. Yusuf Abubakar. Yusuf Abubakar. Aiwaga.
Can I collect for you?
I see.
And then you can give me Yusuf Abubakar.
Which level? Okay, the other person completely sinful. Since morning.
How far?
Have you captured the guy?
You mean one person? Yes, yes. You still made the fish. You need to capture them.
No, I made the person I said is as he has been captured. Hello, Maye. I just want to be sure that it's the one.
Yes. It's the one
Let's go, let's plan. Let's go. Let's go. We don't have time, please.
All right.
Yeah. Federal Poly, Ilaro, sorry, from Federal Poly, Ile Oluji. Am I correct? Yes. It's called 65/100. Please appreciate, please. Olo Rumaye Isaac from Federal Poly, Ede, scored 73.5. Yusuf Abubakar Mewada from HUK scores 76.5/100. Muhammad Usman from HUK scores 73.5/100. Engineer Barnabas M. Basheyi from Isa Mustafa Agwe, Lafayette scored 90/100. Engineer Buala Jesse Dauda scored 72.5/100. Engineer M.A. Additional scored 79.5/100. Position as follows. The first in my list is Engineer Barnabas M. Bashe. You can come forward, please. The second is Engineer M.A. Additional. And the third position is Yusuf Abubakar Mewada. The fourth is Isaac and Muhammad Usman. Where is the third person? That is Yusuf Abubakar, the other one. What of second position?
Additional.
Where is he? M.A. Additional, where is he? He's not around. M.A. Additional from Federal Poly, Nasarawa. Is he around? Okay. Where is Chairman? Hello.
Okay. Thank you very much for your patience. With this, we come to the end of this presentation. I wish all of you safely back to home. Please, I would like to draw your attention. Anybody that comes here should assume himself as a winner. because right from your institution, you have been selected to represent your institution, then from institution, you represent your zone up to this level. So congratulations to all of us. Thank you very much. And no, present as an presented at the Foreign Assembly tomorrow, inshallah. With the prizes. So all that emerge first, second, and third will collect their certificates at the Foreign Assembly tomorrow, inshallah. Thank you.